Hey guys, good morning and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great, having a good time. So, dear students, quickly let me know in the chats if all of you can see me, if I'm perfectly audible, visible to everyone. Just let me know quickly in the chats with the thumbs ups. Everyone. Quickly let me know in the chats if all of you can see me, if I'm perfectly audible and visible to every one of you. Welcome back, welcome back, welcome back. Welcome back. So guys, just 2-3 more days left, right? So we have to utilize these 4-5 days properly, right? So that you all get benefited a lot out of these sessions which we have planned for all of you. Okay? So quickly let me tell you the schedule. So basically it's going to be today the Inorganic Marathon. Since all of you were continuously asking me, sir, take the Inorganic Marathon, take Inorganic. And finally, it's going to be me and HSP, sir, who are going to do this Inorganic Marathon with you. And this session won't be for more than 4 to 5 hours. But your complete Inorganic Chemistry will be done and dusted in this particular session. Okay, you don't worry about that. In fact, all the amazing tricks, all the shortcuts, all the things by means of which you can solve the questions in lesser time, all those things will be done. Okay, perfect. And at the same time, apart from this particular session, today we have got one more session. Ambika ma'am will be taking the biology revision with the PYQs. But you know what is the best part? You know which one is the session, which one is going to be the game-changing session? Let me show it to you. That is this particular one. I want everyone to open this particular session once. This is top 1000 questions in which 90 plus questions directly or indirectly you'll be getting in your NEET 2023 for sure. This is the session which is scheduled for tomorrow. Tomorrow at 11 a.m. I will be starting this particular session. I want all of you to go to this session and click on the notify me part. And I want these likes to increase right now. Till then, we are not starting. This is going to be the game-changing session, my dear students. I'm telling you again and again, this is the game-changing session. Tomorrow at 11 a.m. I will be starting with the chemistry, followed by your biology, followed by your physics. Okay? Right? So I want you guys to open this particular session first. I should see this like count increasing first of all. It's not increasing, yeah. You're not supposed to do this. You're not supposed to do this, yeah. I should see this like count increasing first of all and click on the notify me because this is the most amazing session, guys. You have no idea how beneficial it's going to be. It's going to take me today the whole day to get the top-notch questions, and tomorrow it's going to be the discussion of those top-notch 1000 questions with you. And again, I'm telling you, directly, indirectly, you'll be getting all these questions in your upcoming NEET 2023 examination for sure, right? It's not done, yaar. What are you guys doing? What are you guys doing? I want everyone to click on notify me and smash the like and mark your attendance. Everyone, quickly. Done? Yes, exactly. Yesterday, it was supposed to be the formula revision of chemistry, but then Ambika ma'am, she had to take the long session, right? Students were asking for class 11th diagrams as well. So I told her to extend the session and do the class 11th diagrams as well. So that's the reason why I cancelled my session and gave my time to Ambika ma'am. Okay? Perfect. So let me see first of all how many have turned the notification on and liked the session and smash that like. Guys, this is, again, I'm telling you, this is the game-changing session tomorrow at 11 a.m., okay? You all have to join this particular session. And I want this like count to be 1K right now, okay? Just do that for us so that it will be a reminder for you so that all of you will join on time tomorrow, okay? So people, are you guys ready for the session then? Let me know quickly in the chats. Are you ready for the session? Are you ready for the session? I'll let you know about the formula revision as well. Just relax. Everything will be done. Just relax. So ready for the session? Give me some fire signs here in the chats if all of you are ready for this particular session. Do smash that like and make it to 1000 quickly. Okay. So, as I promised that, all the inorganic chemistry will be done and dusted in this particular session. So, it's a combined session basically for mainly. It's going to be HSP sir. Sir, एक बार आइए ना.
Hey, very good morning. Namaskaram. Vanakkam.
So, HSP sir will be starting this particular session and I'll come in between to teach. Right?
But what is this? Hit the like buttons.
Done. They're already done. So, people, I'll come in between. HSP sir is going to start with the P block first, right, sir?
Yeah. First of all, I'm going to give you solubility tricks, then P block.
So, HSP sir will be starting with the P block. In between, I'll also come, right? So, as I told you, I'm a lot busy with this particular session, right? This particular session, which is the game-changing session, which is going to happen tomorrow, right? So, do watch this particular session, today's as well as tomorrow's, till the end, because I'm 100% sure, people, your inorganic and biology, right? These are the things which students, they like the most because you get the easy questions out of these two. Perfect. So this inorganic marathon, which we'll be taking together, this is going to for sure boost up your score. And this is, again, I'm reminding you, this is the game-changing session, which is scheduled at tomorrow 11 a.m. I want everyone to join this particular session tomorrow, right? Please and please do that. I'll be starting with the chemistry, followed by biology, followed by physics. Okay, sir?
Yeah, definitely we are going to teach from the basics. We will let you know each and everything, right?
Sir will be starting from the basics, but the speed will be comparatively fast because it's whole inorganic. It's not like one or two topics, right? So are you guys ready for it?
What always
Someone is asking about the physical chemistry marathon. Physical chemistry marathon already I have taken. You can check the channel. Go to the live section. There already I have taken two sessions for that. You can watch that session at 2x speed, right? Okay, just go to the live category. I have already taken 2 marathons like 3-4 days back only. For the physical chemistry, you can watch that at 2x speed. That's absolutely going to be beneficial for all of you. At least there are some 7 chapters which I have discussed. Okay? Perfect. So, sir is going to continue now. Sir, take it.
Okay.
I'll come in between now.
Yeah. So before I start, if you're new to this channel, yes, do subscribe the channel, and my dear kids, hit the like buttons. I want to see the josh. I want to see the energy level, and make a promise. Whatever I'm telling you, you are going to feed it in your brain. First of all, everyone, yes, do make a promise that whatever I'm going to tell you from the basic. Speed will be a little bit more because I have to cover each and everything of inorganic chemistry, and Wassim sir is there. My dear kids, first make a promise that whatever I am going to tell you, you have to feed it in your brain. Then only you are going to answer the questions. Otherwise, you won't be able to do the questions. Are you getting my point? Thank you. So, once again, I welcome you all on this fabulous Unacademy NEET English channel, and let's start, dear kids. See, everyone, first of all, I am going to start with solubility chart. Solubility. This is the most important thing. Solubility of complete inorganic chemistry. All chemical compounds, whatever the chemical compound is given, I am going to give you the fundamental trick. I am going to give you the fundamental trick for it. See, from the very beginning I am telling you, bonding of equality is good. What is good? Bonding of equality is good. That means if cation is small and anion is also small, that means cation and anion are almost of similar size, then the bond is very good bond. This bond is good bond, and good bond means less soluble in water, less soluble in water, less soluble in water. So if we want to say for a salt to be more soluble in water, then the size difference must be more. If the size difference is more, suppose this is the cation and this is anion, and if I say this is cation and this is being anion, so which is going to be more soluble? Definitely this is going to be more soluble. Why it is being more soluble? This size difference is too much. Here the size difference is too much. So what I can say, if the size difference in between cation and anion is more, if the size difference in between cation and anion is more, then solubility will be more. What I can say, if the size difference is more, then solubility will be more. Solubility will be more. Is this point clear to each and everyone? Do let me know. Do let me know. Then I will tell you each and everything. If this point is clear, then I will proceed further. Are you able to keep this point in your brain? Then you can do all the questions, any question. But before I proceed towards solubility, let me tell you how can you decide which anion is bigger, which anion is smaller. See to it. Smaller anion, fluoride, hydroxide, oxide, these are smaller anion. Now if I talk about large anion, bromide, iodide, chloride is on the borderline, so leave it, and all multi atomic anions. For example, if I talk about ClO3 negative, nitrate, oxalate, phosphate, carbonate, sulfate, chromate, dichromate. Is this point clear to all of you? These are smaller anions, and all the except these two, these are big anions. Except these two, all the multi-atomic anions, they are larger anion. If this point is clear to your brain, now see each and every question you can do. Let me write down. First of all, let me tell you about cations. Cations: lithium, sodium, potassium, rubidium, cesium, francium. Leave francium because it is being radioactive. Beryllium, magnesium, calcium, strontium, barium. Leave radium because it is radioactive. Now, on moving down the group, size increases. Size increases. If this point is clear to all of you, then see to it. This is biggest, this is biggest, biggest, and these are being smallest. Okay, now we are going to start with the questions. Okay, are you ready? Is everyone ready for the questions? See to it, everyone. lithium fluoride, lithium sodium fluoride, potassium fluoride, rubidium fluoride, cesium fluoride. Leave it. Now if I write lithium bromide, sodium bromide, potassium bromide, rubidium bromide. Now if I write lithium iodide, sodium iodide, potassium iodide, rubidium iodide. Now if I write LiClO3, sodium chlorate, potassium chlorate, rubidium chlorate. Now if I write lithium nitrate, sodium nitrate, potassium nitrate, rubidium nitrate. Now see to it, the first one, A1, A, B, C, D, E. Just see to it, this cation is smallest cation and anion is being smallest anion. Small n is small, and here this is being biggest cation, biggest cation, and smallest anion. Now if I say this is your first, second, third, fourth, so out of 1, 2 and 3 and 4, which is being 1, 2, 3, 4, which is most soluble in water? Do let me know in the chat section if you are able to understand. Fourth one is most soluble. See, you got it. This is big cation, small anion, so the size difference is too much. Size difference is too much. Size difference is too much. You can see very clearly the size difference is too much. Size difference is too much. So this is being maximum soluble. Maximum soluble. So I think this one is very much clear to each and every one. Now let's see the second one. If you see the second one, what will you say? This is large anion, and this is being large cation. So out of these three, if I say this is first, second, third, fourth, now which is most soluble? In the B1 which is being most soluble, do let me know what's the answer. If you are able to get it, do let me know in the chat section what's the answer. Yeah, very good. That's really awesome. Now you are perfect. Yes, this is really awesome. So this is the solubility order. Here also this is going to be the solubility order. Here also this is going to be, let me write down here. This was not Cl, this was ClO3. Now here also this is going to be the answer, and here also this is going to be the answer. Agreed everyone? So this is the solubility. If everyone is agreed, do let me know. If everyone is able to understand, do let me know by showing your thumbs up. Yes. If it is clear to each and everyone, see, this is big, this is big, big, stable, big, stable. See to it, big cation plus big anion, big cation, big anion. Solubility is less because hydration energy is less. He is less. Hydration energy is less. hydration energy is less, and here hydration energy will be maximum. Hydration energy is maximum. So solubility is maximum. Solubility is maximum. If this is clear to each and everyone, all these points are clear to each and everyone, do let me know in the chat section that yes, you got it, you got it, you got it. Now I am going to give you some more questions, and do let me know whether you are able to get the correct answer or not. See, question. Arrange the following in decreasing order of, this means, this arrow means decreasing order. Of solubility. Now see to it, everyone. Beryllium sulfate, magnesium sulfate, calcium sulfate, strontium sulfate, barium sulfate. So if I say this is being A, B, C, D, E, A, B, C, D. So which is being most soluble? I want to see the answer which is being most soluble. If you are able to get the answer, do let me know which is most soluble. So see to it, everyone. Everyone see to it. This is small cation, large anion, multiatomic anion, large anion. And here this is biggest cation plus biggest anion. So definitely it is going to be the least soluble, and this is going to be maximum soluble. So I think this point is very much clear to each and everyone. Now the solubility is clear to each and everyone. So this is the order for solubility. I think this point is very much clear to each and everyone. Is it clear? Now I am going to give you some more examples, and if it is clear, do let me know in the chat section with the help of thumbs up that you got it. See to it, everyone. If I write beryllium hydroxide, magnesium hydroxide, calcium hydroxide, strontium hydroxide, barium hydroxide, do let me know which is going to be the most soluble in water. So definitely maximum solubility. See to it, everyone, see to it. This is smallest cation, and hydroxide. Hydroxide is what? Large or small? Small anion. You can see small anion. So smallest cation and small anion. So definitely the size difference is less. And here you can see biggest cation plus smallest anion, size difference is maximum. So maximum soluble. Is it clear to each and every? I think now the point is clear, the basic concept, the logics are very much clear to all of you. Once the logics are very much clear to all of you, do let me know in the chat section that yes, it is clear. Then I will tell you the most important thing of the NCERT. See the NCERT point I am going to tell you. See everyone. See to it, everyone. It's given in NCERT Question is given in NCERT, which carbonate is thermally most stable or least stable. Most stable, it can be asked like most stable, or it can be asked like least stable. Most stable and least stable. See to it, everyone, it's given in NCERT. The most important question for your NEET examination, very, very important question, given in your NCERT also. You can do each and every question of NCERT with the awesome trick. See, if I say I am provided with beryllium, see, beryllium, magnesium, calcium, strontium, barium and radium. Leave the radium. Beryllium carbonate, magnesium carbonate, calcium carbonate, strontium carbonate, barium carbonate. You know that very well that Taj Mahal is made up of calcium carbonate. Why Taj Mahal is made up of calcium carbonate? I think Shah Jahan must be very, very intelligent. Taj Mahal is made up of calcium carbonate, is marble. Marble is calcium carbonate. Now see to it. If I say this is smallest cation, and this is multi-atomic, this is being multi-atomic, so what I would say for multi-atomic anion, what I would say, this is being large anion. So what I have told you, small cation, large anion, bonding of equality is good. I have told you this point or not? Just to let me know in the chat section. I have told you or not that bonding of equality is good. Bonding of equality is good. So this is bonding of inequality. Bonding of not equality and bonding of unequality. And this is large cation, large anion. So this is bonding of equality. Bonding of equality. This is bonding of equality. Then that means this is good bonding. Good bonding, and good bonding means more stable. This is being more stable, so its lattice energy is more. More lattice energy means this is thermally stable. Thermally more stable. This is thermally more stable. Thermally more stable. And this is being thermally least stable. This is being thermally least stable. And that's why it is given in NCERT, and that's why it is given in NCERT that beryllium carbonate requires atmosphere of CO2. If you remember this statement, that beryllium carbonate needs atmosphere of CO2 to keep it stable or to store it. Right? Is this point clear to all of you? Once this point is clear to all of you, the solubility is clear to all of you, show me the thumbs up, then I will give you the next very, very important point about solubility, because this solubility is very much required to get command on complete chemistry, whether it is physical chemistry, organic chemistry, inorganic chemistry. If you deal with ionic equilibrium, if you deal with solution chapter, this solubility is going to play a very, very important role. Now see everyone, can't sure success. Can't. Now before telling you this can't sure success, question can be asked, the most important question, which salt is soluble? Till now we have done with increasing order of solubility or decreasing order of solubility. Till now what I taught you, Till now, I've told you about just to find out increasing order of solubility or decreasing order of solubility. Now the question can be asked, which salt is soluble and which one is not soluble, and which one is insoluble. These type of questions are really very tough, and these are going to help you in equilibrium chapter. These type of questions are going to help you in your equilibrium chapter, like chemical equilibrium and ionic equilibrium, like solubility. It's given over there. So are you ready to find out the answer? Are you ready to get the trick? How many of you want to get the trick? Just to let me know in the chat section how many of you are in need of trick. See, everyone, see to it. I'm going to give you trick for anions of first group analytical chemistry, or I can say practical chemistry, What are the groups? And for them, I am going to give you the trick. If you're not studying properly, you can't get sure success. Can't sure success. What does it mean? Can't sure. Everyone say can't sure success. Now see to it. C for carbonate. A for acetate. N for nitrite. T for thiosulfate. Now how to write thiosulfate? If you don't know the formula of thiosulfate, first of all write down SO4 2 negative. This is being sulfate. Now in place of one oxygen add one sulfur, so it will become S2O3 2 negative. So this is thiosulfate. Is it clear to all of you? This is the formula of thiosulfate. Now sure is sulfide and success is sulfite. This is sulfide and this is sulfite. Sulfite 2 SO3 2 negative, sulfite. Can't sure success. Everyone write down in the chat section. Let me see if you are able to pronunciate it or not. Just do the pronunciation of it. I want to see. You have to write down, yes, can't sure success. Now see how to get the answer. First of all, everyone write down can't sure success or can't sing song. You can even say can't sing song. Which one is better? Do let me know. Can't sing song. C for carbonate, acetate, nitrite, thiosulfate, sulfite. One trick is can't sure success. You can't get sure success. Another trick is can't sing song. Which one is better? First one or second one? Can't sure success. If you're not studying hard, you can't sing song, can't sure success. Okay. Now see to it, everyone. Everyone, focus over here. One, 2, 3, 4, 5. Now carbonate, CO3 2 negative, carbonate acetate, nitrite, thiosulfate, sulfide and sulfite. See everyone, if I add cation to it, cation of it means these are anions, and if I am supposed to make salt, so I have to add some cation. Anion will make salt. So solubility, focus over here everyone, solubility means all carbonates are insoluble, means not soluble, 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 not soluble, not soluble, not soluble. First of all, everyone try to understand what I am saying. All metal carbonates are insoluble, all metal acetates are soluble, all metal nitrites are soluble, all metal thiosulfates insoluble, all metal sulfites are insoluble, all metal sulfites are insoluble. Is this point clear to all of you? First of all, let me know everyone. First of all, let me know everyone. Insoluble, soluble, soluble, insoluble, insoluble, insoluble. Is this point clear? Now see, I am going to deal with exceptions. Exceptions, see to it. Exceptions. Everyone ready for the exceptions? Are you ready? Now suppose if I am saying the cation of carbonates means metal carbonates are insoluble. So whatever I am going to write down over here, the exception, that means that will be soluble. Are you able to understand the point? So see to it. Ammonium, sodium, potassium, rubidium, cesium. All these metal carbonates are soluble in water. Are you able to understand what I am saying? All these metal carbonates, if this carbonate is reacting with 1, 2, 3, 4, 5, these metal carbonates, they are soluble. Now, how to learn it? I am going to give you a trick. See to it. I am going to give you a trick. How many of you are in need of trick? Do let me know in the chat section you need trick. If you need trick, do let me know in the chat section. Yes, you need it. Write down, otherwise I am not going to give you the trick. Write down in the chat section that you need trick for it. You need trick for it. Now this is Neha. This is Neha. Neha. And if I write Rubina, 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 Rubina are keen towards CS, keen towards CS, keen towards CS. What does it mean, keen towards CS? I am going to rearrange it. See how I can rearrange it. See to it. I can write it like this. Neha, Neha, Rubina, Neha and Rubina are keen towards CS. What does it mean? Computer science. Neha means what? Everyone say, Neha means what? Neha means NH4 positive ammonium. Rubina, rubidium. Na, sodium. Keen, potassium towards CS. How many are they? 1, 2, 3, 4, 5. Is it clear? Neha and Rubina are keen towards CS. Is that clear to all of you? Neha and Rubina keen towards CS. Everyone write down in the chat section. Neha and Rubina are keen towards CS. Neha and Rubina are keen towards CS. Let me know in the chat section. Now over here, acetates are soluble except Ag plus and Hg 2 plus. All nitrites are soluble except Ag plus. All thiosulfates are insoluble except means whatever the exceptions I am going to write, they will be soluble. See everyone, Ag plus, Cu2 plus, Pb2 plus, Hg2 plus, Ba2 plus and Bi3 plus. Ag plus, Cu2 plus, plumbous, mercuric, barium and bismuth, these thiosulfates are soluble. All metal thiosulfates are insoluble, but these thiosulfates are soluble. Is it clear to all of you? Now over here sulfides, all sulfides are insoluble except once again this one, ammonium, sodium, potassium, cesium and three more, barium, strontium and calcium, and calcium. Now over here also once again see Neha, Rubina, so this line is very important. Neha, Rubina are keen towards CS because see wherever it is being insoluble, all the salts of Neha, Rubina are keen towards CS. Neha and Rubina are keen towards CS. That means I can say very clearly that all salts of Neha and Rubina are keen towards CS are soluble in water. See to it everyone, I can say one point very clearly, all salts of Neha and Rubina are keen towards CS, are soluble in water. These salts are always soluble in water. Is it clear to all of you? Is this point clear to all of you? Whatever the salt is there, all salts are soluble in water. All salts of these cations are soluble in water. I think this point is very much clear to all of you that wherever it is provided with these salts, any anion with these cations, these salts will always be soluble in water. Now see to it everyone. Second group radicals. If I talk about second group radicals, 1, 2, 3, 4 and 5. See to it everyone. CBI, nitrate oxalate. CBI is nitrate oxalate. CBI nitrate oxalate. What does it mean? Chloride, bromide, iodide, nitrate, oxalate. How many are these? 1, 2, 3, 4, 5. Second group radicals means cations of these. Any cation of these means cation and anion, they are going to form salt. Now let me tell you the solubility. See to it everyone. Solubility. All are soluble, yes, no. In the first group, all were insoluble except 2, and here all are being soluble except the oxalate. Are you getting this point? Except oxalate, all they are being soluble. Now see the exceptions. let me get some space. Ag, Cu, Pb, Hg2 plus and bio wali auntie, see to it, BiO plus and SbO, bio auntie, you know, bio auntie. This is a trick. Cu, Ag and Hg in the pub along with bio auntie. What is the trick? What is the trick? Yes, what's the trick over here? Cu, see to it, let me rearrange it. Cu, Ag and Hg, Ag and Hg in pub along with bio auntie, What is the trick over here, kids? What's the trick? Cu, Ag and Hg in pub along with bio auntie. Can you keep it in brain? Cu, Ag and Hg in pub along with bio auntie. How's the trick? This is just the trick. So see, Ag plus Cu2 plus Pb2 plus Hg2 plus bio auntie, all they are being soluble in water. These are the exceptional cases. You got it? Once if you have noticed it, do let me know in the chat section that this is very much clear to all of you. Now let me proceed. So Pb2 plus now here also Ag plus Cu2 plus Pb2 plus Hg2 plus. Here also Ag plus Cu2 plus Pb2 plus Hg2 plus. Now all nitrates are soluble except BiO plus. All oxalates are insoluble except these are soluble. I've told you NH4 plus, sodium plus, K plus, Rb plus, cesium plus. So this is all about the solubility. If somebody is asking all nitrates are soluble, yes, all cation and anion means all metal nitrates are soluble in water except this plus. All chlorides are soluble in water except these plus. So if once this chart is clear to all of you, done, everyone done it. Now let me ask some questions. See to it. Question is, which salt is soluble in water? Which salt is soluble in water? So A option is magnesium carbonate, B option is copper nitrate, C option is zinc sulfide, D option is zinc carbonate. Do let me know if whatever I have told you that is clear to your brain. If you are able to understand, do let me know what's the answer. Yes, in the chat section, do let me know what's the answer. Everyone, do let me know in the chat section what's the answer. Everyone, I am asking what's the correct answer. What's the correct answer? I want to see. So everyone, the answer is definitely copper nitrate, because all nitrates are soluble in water. All nitrates are soluble in water. All nitrates are soluble in water. So this question is clear to all of you. Magnesium carbonate insoluble, zinc sulfide insoluble, zinc carbonate insoluble. Okay. So this much is clear to all of you. Let's move. Yeah, very good. You got the answer. That's really fantastic. That's really fantastic. Now I'm going to give you the most important trick for heating effect. See to it, everyone. Heating effect. Effect of heat. Another trick. Effect of heat. Effect of heat. Now I am going to deal with logics and tricks. See to it, logic. If I am provided with ammonium nitrate, trick is, first of all, eliminate out maximum amount of water. What is the trick? What is the trick? Eliminate out maximum amount of water. Just eliminate out maximum amount of water. Maximum number of water molecules. See, if you are going to heat it, what will you get? Do let me know. What will you get? How many water molecules can you eliminate out? See, 4 hydrogens. So, 2 water molecules. 2 water molecules. What is being left? What is being left? N, and how many oxygens are left? 1 oxygen is left. You will get N2O. Are you able to understand? Now, let me apply on ammonium nitrate. This was ammonium nitrate. Ammonium nitrate. Now, let me apply on ammonium nitrate. NH4 NO2. Now, if you are going to heat it, now eliminate maximum amount of water. 2 water I have taken out. 2 water molecules I have eliminated out. What is left? Nitrogen and nitrogen. Only N2 is left. Only N2 is left. Are you able to understand? Everyone, are you able to understand? Now see to it. If I heat ammonium dichromate, NH4 whole twice Cr2O7, ammonium dichromate. Now do let me know in the chat section what you can eliminate out. Yes, I want to see whether you are able to understand or not. Yes, let me know, bachcha log. Kids, do let me know. On heating, how many maximum number of water molecules you can eliminate out? Do let me know in the chat section. Let me see whether you are able to understand or not. How many maximum number of water molecules you can eliminate out? I want to understand how many maximum number of water molecules you can eliminate out. See, how many hydrogens? 4 2s are 8. 4 into 2, 4 2s are 8. That means I can eliminate out maximum of 4 water molecules. Okay, 4 water molecules. So, how many oxygens are left? 4 oxygens I have taken out. I have taken out 4 oxygen and all the hydrogens I have taken out. What is left? Chromium, Cr2O3 is left. So, you can do, this is P block. P block questions you can solve like this. P block questions you can solve like this. If you like the trick, show the thumbs up. If you liked it, I want to see the thumbs up. And I want to see the likes also. My dear kids, yeah, I will cover each and everything. We are going to cover each and everything. But first of all, I want to see whether you are able to understand or not. First, to let me know whether everyone is able to understand. If you are able to understand, I want to see the energy level. I want to see the Josh in the chat section. Now see, very good, very good. That's really awesome, really awesome. I can see the Josh. Fantastic, it's really fantastic. So everyone share it to each and everyone so that everyone is going to get these tricks and you have to understand it. Yes, I will tell you about nitrogen also. I am going to tell you each and everything. See to it. Now, this was the effect of heat. Now another trick. Hydrolysis trick. Trick of hydrolysis. Trick of hydrolysis. Trick and logics of hydrolysis. Hydrolysis. See to it, everyone. The trick is, first of all, let me tell you, during hydrolysis, oxidation state generally remains constant. You have to keep this point in your brain. You are supposed to keep this point on your brain, that during hydrolysis, oxidation state does not change. Okay, oxidation state will not change. No change in the oxidation state. Will you be able? No change. No change in oxidation state. No change in oxidation state. Okay, now see, if I am provided with P4O10, what is the oxidation state? Either it can be given like this or it can be given like this, P2O5. What is the oxidation state? So the oxidation state is +5. Now if I react it with water, what I will get? See to it, everyone, see to it. I can get HPO3 metaphosphoric acid, I can get H3PO4, and I can get H4P2O7. All these three are having oxidation state of +5. Here +5, here +5, here +5. Are you able to understand? Are you able to understand? And let me tell you this thing with the help of balanced chemical equation. I am going to show you each and everything with the help of balanced chemical equation. See to it, everyone, see to it. See to it. If I am provided with P4O10, see to it, P4O10 plus water, I am going to get P4O10 plus water, P4O10 plus water. So let me write down HPO3 metaphosphoric acid. Now see to it, how many phosphorus are given over there? 4 phosphorus are given over here, 4 phosphorus. So let me write down 4. Now let me check it out. P4O10. So how many hydrogens? 4 hydrogens are there. So only 2 hydrogens are there. Let me multiply with 2. So see, oxygen 10 plus 2, 12. 4 3 are 12 oxygen. How many phosphorus? 4 phosphorus, 4 phosphorus. How many hydrogen? 4 hydrogen, 4 hydrogen. This point is clear. See, if I write down P4O10 and plus water, and if I write, I have got H4P2O7. Let me try to balance it. How many phosphorus? 4 phosphorus. How many phosphorus? 2 phosphorus. So let me multiply it with 2. Now 4 phosphorus. Now how many hydrogens? 2 hydrogens, and there are 4 2s are 8. So 4. Now how many oxygen? 10 oxygen plus 4, 14 oxygen, and 7 2s are 14 oxygen. Everything is getting clear to your brain or not? Just to let me know. Now C1. See, P4 O10 plus water, and if I am going to write down H3PO4, H3PO4. Now first of all, let me write down their names also. This is known as metaphosphoric acid, metaphosphoric acid. This is known as pyrophosphoric acid. This is known as orthophosphoric acid. Now see to it, how many phosphorus? 4, and here only 1, so let me multiply it with 4. And now how many hydrogens? 4 3s are 12, so 6. Now how many oxygen? 10 and 6, 16, and 4 4s are 16. Each and everything is balanced. I have written all these reactions on the basis of plus 5, plus 5, plus 5 oxidation state. Here also plus 5 phosphorus oxidation state, plus 5, plus 5. Now if I say 2 moles of water, if it is absorbing 2 moles of water, it is giving metaphosphoric, 4 moles it is giving pyrophosphoric acid, 6 moles it is giving like this. So if I add to this 2 moles of water, I will get this. If I add 2 moles of water to this, I will get this. And if I add 4 moles of water to it, I will get that. See how easy it is. If this clear to each and everyone, if you are able to understand, do let me know in the chat section. Yes, this has become very easy. This has become very easy. See to it, everyone. See to it, everyone. And if you are able to understand, do let me know in the chat section that yes, you are getting, because this is the only communication label in between you and me. This is the only bonding label. So, one rand mule, all three are able to understand. One rand mule. If all three are able to understand, do let me know in the chat section. I want to see, then only I am going to give you tricks. I want to see whether it has become easy or not. Just focus on the oxidation state. You can solve any question. Just focus on the oxidation state. Now see, I am going to give you one memory chart. But before that, I am going to give you effect of concentrated HNO3 on metals. Now see, another trick and logic. Next trick and logic. See. So I am going to deal with the most toughest part of inorganic chemistry. I am going to deal with toughest part, and let us try to make it easy. Let us try this toughest part. Effect of HNO3 on metals. I think this is the part of inorganic chemistry or NCERT which you always find difficulty, right? See to it. Let me divide the each and everything in 4 sections. Let me divide it in 4 sections. Okay. First part, second part, third and fourth part, right? 4 parts. I have divided into 4 parts. Now see, in first part I am going to write more than 70% concentrated HNO3. Second part, concentrated HNO3. third part dilute HNO3, and fourth part very dilute HNO3. Okay, highly concentrated, dilute, very dilute. Now if I say in this dilute part, there are two elements, man with Maggie. Maggie man, what's the trick? Maggie man, they are going to release hydrogen gas. Are you able to understand? Maggie man on reaction with very dilute HNO3 is going to release which gas? H2 gas. Are you able to understand? Now if I say Fe Zn tin, they are going to release ammonia. They are going to release ammonia with this. 2 points are clear to all of you. These 2 points are clear to all of you. Maggie man with very dilute HNO3 is going to release hydrogen gas, and iron, zinc and tin, they are going to release ammonia gas. Now see dilute HNO3. If I talk about dilute HNO3, then I will write tin is going to release ammonia only. Everyone see to it. Tin is going to release ammonia only. Fe and Zn, they are going to release N2O. And dear kids, if I say lead and silver, they are going to release no gas. That means NO gas. Do remember Cu, Ag and Hg in the pub. Do remember Cu, Ag and Hg in the pub with no gas. This is the trick. Cu, Ag and Hg in the pub with no gas. And over here all will release NO2 gas, naughty gas. This is the naughty gas. And here all crocodile. What is the trick? All crocodiles have become passive. Towards Fanny. You understand Fanny? So with highly concentrated HNO3, these elements chromium, cobalt, ferrous, nickel, all they will show passiveness because they forms oxide layer. If this is clear, this chart is clear to each and everyone, do let me know in the chat section that yes, you got it. What I am talking, if you react these four elements, chromium, cobalt, iron, nickel with highly concentrated HNO3, they will form one oxide layer, and further they are not going to show any reaction. If you react any metal with concentrated HNO3, all elements, they are going to react with concentrated HNO3 with the liberation of NO2 gas, and they are going to release NO. This is really very important. These four elements, they are going to produce NO gas, and this question has been asked in number of examinations. Kids, if this is very much clear, do let me know in the chat section. I want to see, yes, if it is fed in your brain, I want to see whether it's working or not. Oxide layer is formed. So what is the trick? All crocodiles have become passive towards Fanny. This is the trick. Let me write down the trick over here. All crocodiles have become passive towards Fanny. I think this point is very clear that what are those elements which are passive towards concentrated HNO3. So this is the trick and it will work, right? Now I am going to give you one memory chart for oxyacid of phosphorus, another memory chart for oxyacid of sulfur. I am going to give you in the starting two memory charts. Are you ready? But before that, I am going to tell you one more logic. See, the important logic before giving you memory chart, mind map of oxyacid of phosphorus, oxyacid of sulfur. Let me tell you the most important thing. Are you ready, everyone? Yes. See, suppose if you are provided with most important trick, most important logic and trick. See to it, everyone, see to it. If I say I am provided with P4, white phosphorus, white waxy, poisonous phosphorus. This is stored in water. If it is in water, it is being stable. Okay. Now suppose if this phosphorus has reacted with chlorine, two options are possible. If this phosphorus is reacting with chlorine, Cl2, here excess of Cl2, here less amount of Cl2. What do you think? Phosphorus can show two types of oxidation state, that is being +3 and +5. See to it. It will form here PCl3 and here it will form PCl5. Is it okay? Is it okay to each and everyone? Here +3 oxidation state, here +5. But difficulty arises when they are going to give the reagent that is of sulfur. See, if they are giving you sulfur reagent, for example, if they are giving you SOCl2, thionyl chloride, this is being thionyl chloride. See to it, thionyl chloride. And here they have given SO2Cl2. Now these two reagents are really, they are given in NCERT, but these are going to create problem. How many of you want to have the trick for it? Just to let me know. You can understand they are given in NCERT, both of them are given in NCERT, but most of the time you are getting negative marks. So how many of you want trick for it? See everyone, here the oxidation state is smaller, small oxidation state, and this is large oxidation state, higher oxidation state, I can say higher oxidation state, right? Now see to it. This sulfur's oxidation state is how much? X minus 2 is equal to 0. So X is equal to +4. Here it is +4. Small. For small oxidation state, you got small oxidation state. And see here, x minus 4, see to it everyone, if I say this is being x minus 4 minus 2 is equal to 0, so x is coming out to be plus 6. So higher oxidation state is going to give you higher oxidation state. Are you getting this point? Is this much is clear to all of you? Once this much is clear, see to it, the journey is still there. Now if I react this compound with water, if I am going to react this compound with water, see to it, if I am going to react this compound with water and if I am going to react this compound with water, what you are going to get? During hydrolysis, oxidation state does not change. During hydrolysis, oxidation state does not change. So see, if I react with water, I will get H3PO3 because the oxidation state will remain same, and if I react with water, first of all I will get POCl3, and this is also going to be a problem. Why we are going to get POCl3? I will let you know. This is unstable. This is being unstable, and then finally it will convert into H3PO4. So why we have got this intermediate? What's the reason why we have got this intermediate? Let me explain it. First of all, let me know, is this point clear to all of you? This each and everything I have taken from NCERT only. All these things I have taken from NCERT only, NCERT P block, NCERT only. If this much is clear, do let me know in the chat section. Yes, if this much is clear, I want to see your energy level. My energy level is very high. I want to see each and everyone's energy level. Do let me know. Everyone, I want to see the energy level. First of all, show me the thumbs up and just click the like button, hit the like button, and if you're new to this channel, do subscribe the channel. Kids, how much is your energy level? I want to see in the chat section. I'm giving you so awesome tricks, logics. If their logics are really very awesome, do let me know in the chat section. Yes, it's working. I want to see the fire in the chat section. Yeah, now I can see, yes, you are energetic. This I can see in the chat section. Yes, kids, yes. Now see, I'm going to explain the reason for it. Why we have got this POCl3. How many of you need explanation, reason for it? See to it, reason. I'm going to give the reason. See, when we are provided with PCl5, if we are provided with PCl5, phosphorus belongs to fifth group. Phosphorus is having how many electrons? 1, 2, 3, 4, 5, because it belongs to 5a, that is Nicogen family, right? Nicogen family. Is it clear to all of you? Now see, it is having 5 electrons, and how many chlorines are there? 5 chlorines. So chlorine is having 1, 2, 3, 4, 5, 6, 7. So now 8. Chlorine 8. Chlorine's octet is completed. Now phosphorus is having 5 sigma bonds. So steric number is how much? 5 sigma bonds plus 0 lone pair. So 5. How much is the steric number? 5. So what is the electronic geometry? sp3d. Now 5 sigma bonds and the electronic geometry is going to be trigonal bipyramidal, right? Trigonal bipyramidal. Is it okay? Is it clear to all of you? Now how it will look like, how PCl5 will look like? See to it. PCl5 will look like this: phosphorus and 1 chlorine and 1 chlorine. These chlorines are being at the equatorial position. This chlorine. These 3 chlorines will be at the equatorial position, right? these chlorines are going to be at equatorial position at 120 degree, and these positions are known as equatorial. Now how I have divided it, like sp3d, I have divided it like sp2 plus pd. Now see how much is the S character over here, how much is the S character at this position. Percentage of S character is how much? 33%. In these bonds, these are being sp2, all three are being sp2, right? They all are having percentage of S character, that is being 33%. But if I am going to write PD, no or negligible percentage of S character. Now what do you think, dear students? These bonds are going to be larger bonds. These bonds are going to be larger bonds. See, these bonds are going to be larger and thinner. These bonds are going to be larger and thinner. Are you getting my point? These two chlorines are going to be larger and thinner. Larger and thinner. These are known as axial bonds. Axial bonds. And if I talk about these bond lengths, these bonds are stronger bonds. Because they are having percentage of S character. These are weaker bond or poorest bonds. These are poorest bonds. Are you getting my point? This much is clear to all of you? Is this much clear to all of you? If I say the bond length, if I talk about even for the bond length, it is 202 picometer, and that is going to be 240 picometer. So these bonds are lengthier without percentage of S character, and these are poorest bond. So these two bonds will break first, and on the basis of this I am going to give you the most awesome trick. See everyone. So whenever I am going to write PCl3, I can draw it like this. 3 chlorines are like this, and 1 chlorine weak bond and the chlorine weak bond. Can you see, everyone? Can you see to it? These are strongest bond and these are poor bonds, weaker bonds, poor bond. Now what will happen? Once the water is going to approach over here, what will you get? What you are going to get? You will get, yes, everyone see to it, you will get HCl. Now you are going to get POH, OH, Cl. At one atom, two OH are not stable, so water will get eliminated out. So what will you get? You will get POCl3, and later on all these three will also go away. So these three are equatorial bonds. And if I talk reaction with PCl5 reaction with alcohol or acid, it will work. It will definitely work. See to it. Everyone see to it. If I am going to write down any alcohol ROH, and if I am going to react it with PCl5, so how it is going to show reaction? Cl. These chlorines are like this, and this chlorine will approach over here, and this chlorine will approach over here. What will you get? You will see that this HCl has eliminated out, and this RCl has eliminated out, and this is POCl3. Can you see? So what's the answer? You will get RCl plus HCl plus POCl3. And same thing with the acid. This you have seen in your organic chemistry, and this is given your inorganic chemistry. Is it clear to all of you? Is it clear to all of you? Are you able to understand or not? Just do let me know in the chat section. Yes, are you able to understand or not? Now see, everyone, if I react this same compound with carboxylic acid, see to it. If I am going to show reaction with carboxylic acid, then I will see R C double bond O OH and same PCl5 P Cl Cl 1 chlorine equatorial 1 or axial 1. This is being axial 1, axial chlorine, big bond, and all these three are equatorial chlorines. Now what will you get? Just do let me know what you are going to get. This carbocation is stabilized by back bonding. So it will form a bond from here, and you are going to get RCOCl. You will get HCl. Now what is left? POCl3. You can see very clearly you are going to get RCOCl, HCl plus POCl3. If this trick is clear to all of you, if you are able to understand, do let me know in the chat section. Yes, you got it. You got it. Just do let me know in the chat section that yes, you are able to understand it. So you can go through it like this, and those who are unable to understand it, let me make it clear. R C double bond O H. Those who are unable to understand, C P Cl. All these are being equatorial bonds, and this is being axial bond. This is being axial bond. Now you can see very clearly what you are going to get. Everyone, see to it. POCl3. You will get POCl3, and you can see over here what you are going to get. HCl and RCOCl. Are you able to understand? Do let me know in the chat section that yes, this is clear to each and everyone. Dear kids, RCOCl plus POCl3 plus HCl. Yes, do let me know. Everyone, do let me know, kids, if you are able to understand. Yes, show the thumbs up. It is clear to all of you. If it is clear to each and everyone, now see, everyone, see to it. Now I am going to tell you the color theory of coordination chemistry. I am going to give you the trick, best awesome trick for coordination chemistry, compounds, color. But let me go P block like in this way. This is the periodic table. One thing must be very much clear. You have to know, you have to keep in your brain the elements like group wise as well as horizontal rows period wise. See, if I talk about hydrogen, lithium, say everyone along with me, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Once again I am repeating, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, beryllium, magnesium, yes, beryllium, magnesium, calcium, strontium, barium, radium, boron, P block, boron, aluminium, gallium, indium, thallium, carbon, silicon, germanium, tin, lead, nitrogen, phosphorus, arsenic, antimony, bismuth, oxygen, sulfur, selenium, tellurium, polonium, fluorine, chlorine, bromine, iodine, astatine, helium, neon, argon, krypton, xenon, radon. You should know. You should know up to this. And like this, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, sulfur, chlorine, argon, potassium, calcium. This row is also important. Potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, gallium, germanium, arsenic, selenium. This much you should know, then we can move ahead. Now see everyone, we are going to start from here. We are going to start from here. Is everyone ready? This P block is very, very important. This P block is really very, very important, and we are going to start from here. Are you ready? If everyone ready, show the thumbs up. Show the thumbs up. Everyone ready? Okay. Now boron family. Boron, aluminum, gallium, indium, thallium. But before moving towards boron family, there is one thing which we should know very well. See to it. Then only we are able to understand these questions. See to it. Everyone. Here is boron, and let me write down the fourth period elements: potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Now see, gallium, bromine and krypton. Now see to it everyone. Boron, aluminium, gallium, indium, thallium. Now what I want to tell you, gallium is over here after these elements. These are having d orbital filling, d subshell filling, and d is diffused. D is being diffused. Diffused means, if you remember, its screening is poor. I have told you screening effect is very much what? Good or bad? Screening is poor. Screening means what? Shielding effect. Shielding is poor. Okay. Now this D subshell, because when the nucleus is applying force on the outermost electron, what do you think? On moving from left to right, effective nuclear charge will increase. Effective nuclear charge will increase. So this D subshell will create a lot of problem over here. Where? From here to here. This is going to create a problem. Because of shielding effect, trends will be irregular. Trends will be irregular. Trends will be irregular. So whenever we are going to deal with this block, boron block, the third A block, we have to keep this point in our brain that the shielding is very, very poor. Are you ready? Are you able to understand what I am talking? Whenever we are going to deal with this block, means up to boron and aluminum, everything is okay. No problem. Here is no problem. Why there is no problem? Because D has started from here. D has started from here, and this all they are having 3D electron filling, and this is going to create a problem in these three elements. Is it clear? Should I start? Should I start? Okay, I am going to start and focus over here. See, the point to be noted, very, very important point, ionic radius. This atomic radius and ionic radius, these 2 points are very, very important. As we know that on moving down the group, atomic size, if I talk about atomic size, as we go down the group, as we generally, I am talking about generally as we go down the group, size increases, but here will be anomalous behavior. You have to see to it what difference this poor shielding is going to create. See everyone, no need to learn the values, but we have to follow the trend. This is being 85 picometer, 85 picometer. This is in 143, 143, but this is only 135. This is only 135. Why it is 135? Even smaller than aluminium. Size of aluminium is bigger than, means size of aluminium is more than that of gallium. Aluminium size is 143 picometer and gallium is, we can say like this, or we can write down like this. Gallium is just 135 picometer, 135 picometer. So what's the reason behind it? Could you please let me know in the chat section why the size difference is there? Why? And now it started increasing. Now size started increasing, but here boron, aluminium and gallium, there is size almost equal. What's the fundamental thing behind it? Just to let me know. That is due to poor shielding of what? Yes, poor shielding of what? Kids, do let me know. Poor shielding of D subshell, D subshell. So this point is very, very important. Now ionization energy, this point is also very, very important. See everyone, ionization energy. Boron is having 800, then 577, then 578, then 558, then 590. There is no regular trend. See, which is having maximum ionization energy. See, is this the correct order? Is this the correct order? See to it. If I talk about the values, no need to learn the value, no need to remember the value. Boron is having maximum. See, boron is having maximum. Then it's thallium. Thallium is having after boron, thallium. Where is thallium? 590, right? This is right. Boron, then thallium. After thallium, there is gallium, right? This is right. Then aluminium, then indium. So we have to remember this is very, very important. Very, very important. Bottle, galley, all India. Trick is boron and thallium. Bottle, gal, India. Bottle, gal, India. Do remember the trick? Bottle, gal, India. Remember that? Bottle, gal, India. Okay. Now, these two things are really very, very important. One is being atomic radius and second is being ionization energy. So this ionization energy's order is really very, very important. Is it clear? These 2 points are clear to all of you. Do let me know. Do let me know these 2 points. They will be asked number of times. Examiner has been asking these questions. Do let me know. Bottle, gal, India. Yes. This is the trick. Bottle, gal, India. Bottle, gal, India. So what is the trick, kids? What is the trick? Do let me know. Ionization energy. Ionization energy trick is, this is the very, very important point. Do let me know in the comments chat section what trick I have told you, kids. For ionization energy in kilojoule per mole. What trick I have told you, kids? Do let me know. Bottle, gal, India. Bottle, gal, India. This ionization energy is increasing in this order. Bottle, gal, India. Okay, is this point clear to all of you? This is really very, very important. Bottle gal India. Bottle gal India. Okay, now the stability of +1 oxidation state. Before we move toward this question, let me tell you inert electron pair effect. See to it. Inert electron pair effect. Everyone see to it. If I talk about boron, aluminium, gallium, indium, thallium, how should I write the electronic configuration? Its atomic number is 5. So what I am going to write? 1s2, 2s2 and 2p1. So outermost electronic configuration is like this. Now I will write 3s2, 3p1. Now I will write 4s2 and 4p1. But here I am supposed to write down what? 3d10. Can you see 3d10? Now let me write down 5s2, 5p1, 6s2, 6p1. Now I am supposed to write down here what? 5d10 and 4f14, right? Now whenever the nucleus is applying force, this F and D, they have got very poor screening effect. D and F, very, very poor, very poor shielding effect. Due to very, very poor shielding effect, they won't be able, or you can say they will apply more force of attraction on the S subshell electron. They will apply more force on the S subshell electron, right? So these electrons won't be able to participate in the bonding. That means 6s2 electrons won't be able to participate in bonding or can't get oxidized easily. So it will show +1 oxidation state. That means I can say S electron will show inertness. S electron will show inertness towards oxidation. 6s2 electrons will show inertness towards oxidation. Am I right? So on moving down the group, only this one oxidation state going to be common. So the stability of +1 oxidation state, among aluminium, gallium, indium and thallium increases in the sequence. This is the question of 2015. What's your answer? What's your answer, kids? Just do let me know. What's your answer? I want to see the answer. Kids, if you are able to understand, show. Yes, show your energy level. I am waiting for your answer. Kids, I am waiting for your answer. I am waiting. B for Bahubali. Everyone is writing B for Bahubali. Let me see. Increases in the sequence, the stability of +1. So boron, aluminium, gallium, indium, thallium, everyone is going for B. Let me see. Let me see your answer is right or wrong. Yeah, absolutely correct. You got 4 marks. Everyone got 4 marks. Are you happy? Everyone, do let me know. Are you happy for this question? Just do let me know, my kids. Dear students, you got 1 randa mool nale 4 marks. 4 marks. Okay. Now boron if reacting with oxygen, boron's oxidation state is 3. Boron's oxidation state is 3. They all will form B2O3, Al2O3 like this. And here Bn, boron nitride, is very, very stable compound, hard compound, hard compound. Do remember this is being hard compound. Simple reactions. These are simple reactions. No need to tell you any trick. Simple reactions. These are simple reactions. What I'm telling you, when boron, aluminium, gallium, indium, thallium, they are reacting with oxygen, they are having 3 oxidation state, and definitely this is going to react at high temperature. Now, boron family chemical properties, reaction with alkali and acids. Now see, if I talk about boron and NaOH, see how to write. Just before this you got B2O3, you got B2O3, you got B2O3. Now see, B2O3 when reacts with water, what will you get? H3BO3 you will get. This is boric acid. This is boric acid, right? And NaOH is what? Base. NaOH is what? Base. What do you think? In class 10th, what you have studied? When acid reacts with base, what will you get? Do let me know in the chat section when acid reacts with base. Otherwise, I am not going to tell you anything. When acid reacts with base, what will you get? When acid reacts with base, you will get salt and water. Salt plus water. Am I right? Salt and water. So this is acid, that is being base. When they are reacting, what they are going to produce? It will produce salt, Na3, because this 3 Na3BO3 plus water. Is it clear? Acid plus base reacting, they are going to give you salt and water. Is this point clear to all of you? Do let me know if this is clear to each and everyone, kids. Is it clear? Okay, next question. Aluminium chloride in acidified aqueous solution forms a complex A. What they are writing? Aluminium chloride, see, aluminium chloride, that is AlCl3, is reacting with some complex A, some acidified aqueous complex A. Acidified aqueous complex. In which hybridization state of aluminum is B. What are A and B respectively? Yes. Could you please help me to know, to understand the answer? Yes. What answer you are going to get? Aluminium chloride, aluminium's oxidation state is +3. Aluminium chloride in acidified aqueous solution forms a complex A, in which hybridization state of aluminum is B. So, what are A and B? It must be some error over here. This is NEET Odisha 2019 question. Do let me know what the answer you are going to get. Yes, everyone, I want to see the answer. What logic you are going to apply? What logic you can apply? Yes, everyone. Water is weak ligand. So, see everywhere, what is weak ligand? Water is being weak ligand. H2O is weak field ligand. So, let me check it out. Bahubali. Everyone's answer is correct, that you got Bahubali. And see, sp3d2 outer orbital complex. Why you got outer orbital complex? Outer orbital complex, you got it because of H2O is weak field ligand, weak field ligand, weak field ligand. Okay, now another question. So boron family, if we talk about hydrides, so this is really awesome important reaction of NCERT, that if you are reacting with LiAlH4, what is LiAlH4? LiAlH4, you can write it like this: Li positive, AlH4 negative, and you can even divide it like this: LiH and AlH3, and this is plus, this is minus. So Al, you will get Al, H, H, H and H. So this is very good hydride donor, very good hydride donor, very good hydride donor. Is it clear to all of you? And that's why very strong reducing agent, and that's why it is being very strong reducing agent, very strong reducing agent. So what it is going to do, this lithium aluminum hydride can be written like this, LaH, or it can be written like this, lithium tetrahydroaluminate 3. You can get it like this also, lithium, its IUPAC name is lithium tetrahydroaluminate 3, aluminate 3, and it is highly explosive, violent reaction with water. So it must be kept away from water. LiLH4 must be kept away from water. That's why dry ether has been used. Highly explosive towards water, highly explosive towards water, So it will produce hydrogen, and this will convert into BH3 and then diborane, and diborane, you know very well, I have told you diborane is having banana bond. Are you getting my point, kids? Are you able to understand? Boranes are stable, but the stability of hydrides are these and decreases. See why, how to understand this point. I am going to give you the logic. Already I have given you the logic. See what they are writing. If I talk about boron, aluminium, gallium, indium, thallium, now they are saying that hydride stability is decreasing. BH3, AlH3, GH3, indium H3, TlH3. See the previous slide. Boranes are stable, but the stability of hydrides of aluminium, gallium, indium decreases on moving down the group, Now see everyone. They are saying this is being stable, stable hydride, but here stability decreases, on moving down the group, Now just apply the logic. The logic I have told you. Which logic I have told you? Bonding of equality is good. I have told you or not? Bonding of equality is good. I have told you or not? Bonding of equality is good. That means thermally stable. That is thermally stable. So see, hydrogen is small and small. Hydrogen is small and small. Small plus small will be stable. Small plus small will be stable. So this is small. Boron is smallest in its group. This is being small, stable. This is large, and this is being small, highly unstable. Now this logic is working everywhere. This logic is applicable everywhere. Are you able to understand, kids? Now what is this? I can't see the energy level. This logic I am telling you from last number of days, this logic is working or not. Do let me know. Everyone, do let me know this logic is working or not. This logic I am telling you from number of days, and it's applicable everywhere. It is applicable everywhere. Do let me know in the chat section. This logic, bonding of equality is good. This logic is working everywhere or not. Bonding of equality is good. Thermally stable. Kids, do let me know in the chat section, and keep yourself hydrated. I am telling you number of logics, but yes, these logics are applicable everywhere. People used to say inorganic chemistry is full of exceptions, but I would like to say no exception is here. Just try to understand the logic. I am giving you logics. PDF I will share definitely. Kids, do let me know in the chat section. I am telling you each and everything from the NCERT only, right? So let's move ahead. Oxides, I have told you M2O3 formula. Except thallium, all elements of group 13 form oxide of. Now let's deal with this also. What they are writing this point, see to it. Everyone, what I have told you, bonding of equality is good. This logic I have told you or not? Bonding of equality is good. Or I can say if size of cation and anion is of almost same size, if the size difference is less between cation and anion, if the size difference is less, compound will be more stable, right? Compound will be more stable. Agreed or not? Just do let me know. This thing I am telling you from number of days. If the size difference is less, the compound is going to be more stable, right? If the size difference is less, compound will be more stable. Clear? Now if I talk about this boron, aluminum, gallium and thallium, boron, aluminum, gallium, indium, thallium, and if I say oxide, I have told you small or large. Oxide was small or large? Small anion. Small anion will be more stable with small or large? Definitely this is small. So B2O3, small and small, stable, because size difference is less. Because here the size difference is less. Kids, are you getting my point? Size difference is less. And if I talk about thallium, Tl2O3, highly unstable. Why? Just to let me know why thallium oxide is boron, aluminum, gallium, indium, thallium. Thallium oxide is least stable. Do let me know. Everyone, do let me know why this is least stable. Because this is large cation and small anion. Is this point clear to all of you? That's why they have written M2O formula. Nothing to cram. All the logics I am giving you. Logics means if I say thallium oxide, then thallium size, cation size is big and anion size is small. That's why it is not stable. Everyone, are you getting my point? Everyone, are you able to understand? Yes, because of large size difference. Yes, very good, very good. That's really awesome. That's really awesome. Now see, anomalous behavior of boron. Always remember, when any element is going to belong with second period, any element of second period, any element like boron, carbon, nitrogen, oxygen, fluorine, they all belongs to what? They all belongs to second period. And if element belongs to second period, they are very, very small. They don't have vacant 2D. There is no 2D. So they are very, very small in size. Very, very small in size. Very, very small in size. So they will show anomalous behavior. Will show anomalous behavior. Right? So these are the points you should keep in your brain, that borons, it is a non-metal while other members of group are metallic. Non-metal, only boron is non-metal. This is the point you should keep in your brain. Boron is the only element in third A which is being what? Non-metal. If I talk about boron, aluminium, gallium, indium, thallium, so this is the only element which is being non-metal. Rest of all others are metallic. So this point is very, very important. It may come in your exam. It shows allotropy while other members do not show. This is also very, very important point. Now see, this is really very, very important point. The halides of boron exist as monomeric while AlCl3 exists as dimer. This question has been asked number of times in the NEET examination and when there was separate examination. Very, very important. Very, very important. Now see, the oxides and hydroxides of boron are weakly acidic while those of aluminium are amphoteric. Let me tell you this point. And let me explain this point. Metal oxides are basic. As the oxidation state increases, non-metallic character increases. Are you getting my point? Now, if I say CO, NO and N2O, these are the only three oxides which are neutral in nature. Neutral oxides. In this world, there are only three oxides which are neutral. Now, amphoteric oxides. If I talk about amphoteric oxides. So, amphoteric oxides, you know very well that these amphoteric oxides can react with acidic oxide, they can react with basic oxides. So, the most important amphoteric oxides are oxides of these metals oxides are amphoteric in nature. These are neutral. These are being neutral. Remember that. These are really very, very important point. These are being neutral and these are amphoteric. Are you getting my point, everyone? Do let me know. Is everyone able to understand? These are amphoteric in nature. Can you see? These oxides are amphoteric in nature. All these are being amphoteric in nature. Clear to all of you? This one point I have told you. I have told you this point. A point I have told you. This B point I have told you. And this C point I have told you. Is it clear to all of you? Do remember these things in your brain. They are going to really help you out. Break. Okay. After two slides, I will give you break, right? First, do let me know right now how is the energy. I want to see how much energy is still left. You are full on energy, full on Josh, or your energy is getting decreased. I want to see in the chat section. Hey kids, do let me know. Everyone, I want to see your energy is still as you were having initially or it's getting decreased. I want to see kids. So, wow, really great. So, first of all, let me give you two memory charts, then I will give you break. Is it okay? Let me give you two memory charts. Are you ready? So, do let me know in the chat section you want memory map. Memory map, those two memory maps are really going to give you at least 20 marks. Those two memory maps really they are going to be you 20 marks, at least 20 marks. Are you ready everyone? Do let me know in the chat section. Yes. Wow, really everyone so excited. I can see everyone is so excited. Okay, let me give you memory map. See. Let me first of all complete this, then I am going to give you the memory map. See, let me complete this, then I am going to give you memory map. See, this BF3LILH4 is giving you B2H6 and this is really very, very important. I have told you yesterday that B2H6 really it is very, very important and this is very, very important. Let me explain it. See to it everyone. See to it everyone. You should know each and everything about it. This is one boron. Just try to copy it in your brain. It should go into the hippocampus. Everyone ready? Just right now try to put it in your brain. Boron, one boron, second boron. These four terminal hydrogens, one terminal hydrogen C, one terminal hydrogen, second terminal hydrogen, it is going away from you and it is coming towards observer side. This is coming towards observer side. This is going away from observer side. These four hydrogens are four terminal bonds I have drawn. Terminal bonds. Four terminal bonds. Even the examiner can ask whether they are in the plane or out of the plane. So, they are in the plane of boron. In the plane of board. In the plane of your copy. In the plane of your notebook. Your copy. Like this is the copy. Let me show you. If this is the copy, one boron at this place, one boron at this place and four hydrogens, one hydrogen going towards your side, coming towards your side, one hydrogen is coming towards my side, one hydrogen going towards observer and towards my side. All they are in the copy. Now see, one hydrogen will go above the plane and one hydrogen will go down the plane. Are you getting my point? Everyone do let me know. Are you able to understand? One boron here, one boron over here and all hydrogens just at the corners, at the four corners, the four hydrogens are going. Are you getting my point? Everyone do let me know. Are you able to understand? Now see, everyone see to it. These are four terminal bonds in the plane of your copy. And what is the bond length? If I talk about the bond length, then definitely the bond length is, because this is the most important question which can be asked. The bond length is, the trick I'm going to give you, see, AAI with PM. AAI with PM. What does it mean? AAI with PM. A for ABCD 1, 1, and in ABCD, see, A, B, C, D, E, F, G, H, I. What number I can quote? See to it. 1, 2, 3, 4, 5, 6, 7, 8, and 9. 9. 119 picometer. Okay, this is given in an NCERT. It is given in your NCERT, so it is really very, very important. It is given in an NCERT. Now see, these are known as two-centered two-electron pair bond. Why they are known as two-centered two-electron pair bonds? Because two orbitals and two electrons have been shared. This is one boron's electron and this is hydrogen's electron. So two atoms and two electrons. I can say two atoms and two electrons bond. Is this much clear? Now see, one hydrogen is going above over here. See, at this place, above the plane. So one atom, two atom, three atom. How many atoms? Three atoms. Three centered two electron pair bond. And the one hydrogen is going downward side. You can see like this. It's moving downward side, and its shape is like this. See, the bond is formed like this. Can you see? It's bent bond. And same over here. It's bent bond. Can you see? Bent bond. The bond is being bent bond. Bent. Either you can say bent bond or you can say tau bond. Tau bond, or you can say banana bond, because the shape is like banana bond. So they are lying perpendicular to the plane. They are lying perpendicular to the plane. Are you getting my point? Above the plane, below the plane, and their bond length is more. Bond length will be more. How much bond length can you think? So it is BDO, or it's, I must have told you ACD, acid PM. What does it mean? Acid PM 134 picometer. So it is weak bond. Banana bond is being weak bond. This banana bond, bent bond is weak bond. Weak bond. Is it clear to all of you? So it is having two types of hydrogen bonds. It is having two types of hydrogen bonds. B2H6. If I talk about B2H6 kids, how many types of bonds are there? Two types of bonds. Two types of boron to hydrogen bonds. What are they? There are four terminal bonds. Four terminal bonds in the plane of paper or this board or your copy, and they are known as, yes, two-centered two-electron pair bond, because this type of bond is formed in between two atoms orbital and two electron. Now another type of bond is being banana bond, big bond, banana bond is being weak bond. Now if I talk about, this is known as three-centered 2-electron pair bond. Why it is known as that? Because this bond is formed between 3 atoms orbital but only 2 electrons, only two electrons, that's why it is a weak bond. It's a weak bond, weaker bond, and this is being stable bond. Is it clear to all of you? Is this much clear to all of you? Are you getting my point, bachcha log? Now see, borax or sodium tetraborate, this borax, and this is really very important. This is really very important. Very important. Number of questions has been asked in your examination based on it. So how many of you want to understand it? First I am going to give you trick not to wake up before 7 o'clock. Let me give you the trick for it. Natu, you know, you understand Natu? Natu, Oscar award winner Natu wake up before 7 o'clock and have 7 glass of water. Now directly you can learn Na2B4O7.10 times H2O. Have you seen this movie, everyone? Natu. Do you know Natu 1? Natu wakes up before 7 o'clock, before 7 o'clock, and he is having 10 glass of water. How is the trick? At least you can show your energy level in the chat section. Now see, Natu wakes up before 7 o'clock and have 10 glass of water. Now see to it, everyone, how to draw structure. Boron, see, boron, east, west, north, south. How many boron I have drawn? Do let me know. How many borons I have drawn? Kids, do let me know how many borons I have drawn. East, west, north, south. Try to feed it in your memory. Try to make a film. Just try to make a film in your memory. See. So, what is this? I am going to put oxygen at this place. I am going to put oxygen. Bob. Now one more Bob. How many BOB linkages I am having right now? How many BOB linkages right now I am having? Do let me know. How many BOB linkages? 5 BOB linkages I am having. 5 BOB linkages I am having. 5 Bob linkages I am having. Am I right, kids? 5 Bob linkages I am having. Now see to it. 1. Let me take another pen. This bond. Now I have added OH. I am adding OH at this place. OH. We know that. What is the stable oxidation state of boron? Boron's oxidation state is main 3. So it is having 4. So I have to place negative charge at this place. This boron is having 3 oxidation state. 1, 2, 3. If the oxidation state of boron is 3, it's okay. But if I am increasing the oxidation state, negative charge. So 2 negative charges, I have to place 2 Na plus. These 2 positive charges will neutralize these 2 negative charges, right? So what actually I was having Na2B4O7 10 times H2O. Now just see to it. Even I can write this structure like this: Na2B4, yes, OH whole 4. Now OH whole 4, oh, how many oxygens in between? How many oxygens? O5. I can write like this, O5. Then see how many oxygens are left. 8 times H2O. Is it okay? Now see to it. Is this right? So in this structure I can add 8 moles of water at this place. Is it okay or not? 8 times of water at this place. Now this structure is okay or not? Just do let me know in the chat section. Are you able to understand it or not? Everyone, just do let me know in the chat section. Are you able to understand it or not? Okay, now everyone is able to understand it. Now see, Na2B4O7 is reacting with HCl. It is giving NaCl and boric acid. Now see to it. Let me tell you about boric acid. This is very, very important. H3BO3. Number of questions examiner is going to ask from here. If I talk about in gaseous state, right now I am dealing with this acid's basicity, that is N factor. Now in gaseous state, it can release this H3BO3 can release 3H plus ions and will form borate BO3 3 negative, but this is in gaseous state only. This is in gaseous state. Now the most important question, if I talk about aqueous state, in aqueous state, this is the most important question, very important question the examiner is going to ask. In aqueous state, in water, what will happen? See, BOH, OH. You can see very clearly boron is having 3 electrons when it was just elemental form, and it has got 4 electrons from here, 3 electrons from here. Now total how many electrons boron is having in the outermost shell? Total only 6 electrons in the outermost shell. Only 6 electrons in the valence shell, right? So it is electron deficient or efficient? Electron deficient or efficient? Definitely it is being electron deficient. It is being electron deficient species, right? Electron deficient. So we are going to say it is being electrophile. Electrophile means electron loving. Am I right or not? Electron loving entity. Electron loving entity. Am I right or not? Or I can say Lewis acid. So when we are going to add it in water, water is like this: HOH, H delta positive, OH delta negative. So this boron will say, hey OH negative, just give me 1 electron. I am in need of 1 electron. This will say I am in need of 1 electron. So boron will take 1 electron like this: BOH, OH, OH, and one more OH from water. And this H plus has came from where? This H plus is from water or BOH3. Just do let me know in the chat section. This is the most important question of your examination. The examiner will definitely ask this question. This H plus has come from water. So examiner will ask, this is acid, and its n factor is going to be 1. Basicity is going to be 1. Basicity is 1, but the H plus has come from water. H plus has come from water. H plus has come from water. Kids, do let me know this point is clear to all of you. In gaseous state, it is going to release 3 H plus ions, but in aqueous state, it will give only 1 H plus ion, and that too not from its original compound. It is going to give 1 H plus from water. Are you able to understand? Kids, do let me know in the chat section. Okay, B2H6 ammonia. This is really very important compound. Very important. Very important. See why. Let me draw the structure of inorganic benzene. This is inorganic benzene, boragene, or if you can say triborine, triborine, triamine, triborine, triamine. See the structure. Focus on the structure, everyone. Try to focus on the structure. Boron, nitrogen, nitrogen, boron, boron, nitrogen, nitrogen, hydrogen, 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 and hydrogen. You can see very clearly boron is having only 3 electrons of itself and 3 electrons from nitrogen and hydrogen. So total of 6 electrons it is having. Total it is having 6 electrons, only 6 electron, and this nitrogen is having 8 electron. What can happen over here? Nitrogen is acting as nucleophile, electron donor, whereas boron is Lewis acid. Are you able to understand? Here nitrogen is nucleophile, that means electron donor, whereas boron is having only 6 electron. So boron will act as, boron is electrophile, that means Lewis acid, electrophile, electron acceptor, or better to say it is having lone pair in 2p orbital and it is having vacant 2p orbital. What can happen? Do let me know. Vacant 2p orbital, back bonding can take place. Back bonding will take place. So who is going to donate electron in back bonding? Nitrogen will donate its lone pair to boron. This nitrogen will donate to this nitrogen will donate to this, and this nitrogen will donate to this. Now how the structure will look like? See to it. It will look like this: boron, nitrogen, nitrogen, boron, boron, nitrogen, and hydrogen, 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 hydrogen. And once they have donated electron, this has donated plus charge, it has gained negative charge, and they have formed one extra bond. Donated, gain, one extra bond, donated, gain, one. So it's looking like benzene. You can see it's looking like benzene. That's why it is known as inorganic benzene. Clear to all of you? It is looking like benzene. That's why it is known as inorganic benzene. See kids, I am teaching you, I am telling you each and everything with very high speed. Are you able to understand? Are you able to cope up with the speed, this much of speed? Are you able to understand kids? Kids, don't worry, have belief in yourself. Let me tell you, afterwards I will drink water. Always believe in yourself. Always believe in yourself and say to yourself that you are definitely going to crack this NEET 2023 exam. Kids, say to yourself, you are an important person. Dear kids, let me tell you, 200 marks you can get only because of believe in yourself. When you say you are an important, you will get cooled down. Right now everyone is thinking whether that student, he or she, will be able to recall each and everything in the exam or not. Okay, everyone is in need of break. Okay. Kids, always say to yourself, you are an important person. Afterwards, I am going to give you the break, right? When you see the confidence in yourself, really you will think you are able, and where there is a high willpower, that person can do anything, can achieve any goal. All the obstacles in your path will disappear and the means to its achievement will appear in front of you. Dear kids, when you wake up in the morning, always say to yourself that you are an important person. And once you think you are able, you are almost too able. And to decide upon achievement, it's an achievement itself. Then all the obstacles are going to disappear and the means to its achievement will appear in front of you. Kids, I really mean it. Those who are thinking that they are not able to recall the thing, do one thing. Should I give you one thing? If you are thinking that you won't be able to recall the things in your examination, then I am going to give you the break. How many of you are thinking that you won't be able to recall the things in the examination? How many of you are thinking? How many of you are thinking? See, suppose today is Wednesday, and on Wednesday, whatever you are studying, suppose you have studied inorganic chemistry. When you wake up in the morning, without, or you can see, just close your eyes, and try to recall the things. Close your eyes and try to recall the things. Try to recall all those things which I have told you today, or you can say which you have studied. Try to recall all the things. Dear students, definitely in air only, you will definitely recall. Each and everything. And this will boost your energy level, confidence level. Really, I mean it. This is going to boost your confidence level. Definitely will give you, or will increase your confidence level. Because in the examination, you won't be getting any notes and you have to think over there in the air only. That's why in the examination, notes are not allowed. Your brain is allowed, and just what is allowed in the examination, try to do the practice of that thing only, so you won't be getting those negative thoughts which are coming to your brain right now. You must be trying to just say, oh, whether I'll be able to recall it each and everything. Yeah, definitely. Now, so I'm going to give a break for 20 minutes, right? 20 minutes break. Right now time is 1:39, or you can say 1:40. 1:40. So 1:42, exactly 2 p.m. Short break. Let's meet with Wassim sir. We will meet sharp at 2, right? Is it okay, kids? Okay? Fine? Just do let me know in the chat section. Okay? Say everyone. Okay, you won't, but this much break is okay. Okay, let me extend it up to 2:15. See. Now is it okay? 2:15. 1:40 to 2:15. Is it okay? 2:15, 20 and 30, 35. 2:10, 2:10, 2:10. Now is it okay? No bargaining please. Now no bargaining please. Okay, I will let you know chemical bonding each and everything. Okay? So kids, we will meet at sharp 2:10 p.m. Do remember this time. Do remember this time. Okay? So I am on time, or better to say in time, right? Now I'm going to give you just after 1 minute, because 1 minute is left. So I will give you the best trick: oxyacid of phosphorus, oxyacid of sulfur, and the preparation of nitrogen oxide. 3 things. So are you back? Have you had your lunch? Have you had something? So see, 1 minute is still left. So after completing P block, I will start with D block, then coordination chemistry. Awesome tricks I am going to give you. So still 1 minute 30 seconds, you can say 30 seconds. Oh, time we need. I am a disco dancer. I will let you know later on, but right now I have to give you tricks. So no, I have some fruits. You can say I've gone through some fruits. I drink only water. Have something to eat better. Otherwise, dehydration will take place. Eat some salad, fruits, because if I am going to take heavy meal, I won't be able to teach, because heavy meals always let you sleep, you know. 18 group, yes, 18 group also. I will go up to 18 group. So those who think, so Vanakkam, welcome back once again to this awesome session, my dear kids. Just to let me know, are you ready? Everyone ready? So let's start the most important, oxyacid. I am going to give you mind map. I am going to give you mind map, dear kids. Right now I am going to give you mind map. Mind map oxyacid of phosphorus, oxyacid of phosphorus. See everyone. H3PO4. Everyone try to just put it in a brain. H3PO4. This is known as orthophosphoric acid. Orthophosphoric acid. And if I take 2 moles of orthophosphoric acid, if I take 2 moles of orthophosphoric acid, see kids, if I take 2 moles of orthophosphoric acid, that means H3PO4 plus H3PO4. If I add these two, what I will get? If I add these two, I will get H6P2O8, and if I remove water from it, what I will get? Definitely I will get H4P2O7. This is known as pyrophosphoric acid. Pyrophosphoric acid. Pyro means heat. So when to use pyro word? Whenever you are removing water molecule, pyro word is used whenever you are removing water molecule from 2 moles of that particular orthophosphoric acid or whatever the ortho acid. you will get pyro. Are you getting my point? Pyro. Now, if you take only one molecule, and remove water, if you take only one molecule and you are going to remove water, what will you get? 610 degrees Celsius, no need to remember this temperature, and if you remove water you will get HPO3. HPO3, this is known as metaphosphoric acid. Metaphosphoric acid. Kids, are you ready? Are you getting my point? Ortho, when to use ortho, when to use meta, when to use pyro. This is being ortho, that is being pyro, and this is being meta. This is not like benzene, ortho, meta, pyro. Are you ready? Everyone, do let me know in the chat section. Hey kids, am I audible and visible to all of you? Do let me know in the chat section. Can you hear me? If I am perfectly audible and visible to all of you, do let me know, kids. I think I am audible and visible to all of you, but kids, show me the thumbs up if I am audible and visible. Hey kids, I can't see the energy level, I can't see in the chat section, I can't see those reactions that I am properly audible and visible. I am on time. What I can see, everyone ready? Yeah, now I can see fire in the chat section. That's really awesome. Otherwise, I was thinking that am I audible, visible or not? People can hear me or can't hear me. Kids, it's my humble request to you, just try to keep it in your brain. Right now, try to keep it in your brain. Just try to feed in your brain. Kids, promise, make a promise that yes, you will do that. Kids, just do promise that you are going to do that. Kids, I'm waiting. This, all these are really very important. Really, they are very important. Just try to keep it in your brain. Try to make it a photographic memory. Then only you are going to get success. So, 3 acids I have told you. Let me show the structures also. It is like P double bond O, OH, OH, OH. This is orthophosphoric acid. This is P double bond O, OH, OH, O, P double bond O, OH, OH. You can see its N factor. Basicity is how much? Here the basicity is N factor is 3. Tribasic acid. Here the N factor is 1, 2, 3, 4. N factor is 4. Basicity is 4. This much is clear to all of you. And here the basicity is P double bond O, OH, and coordinate bond O. Only 1. N factor is 1. Is this much feed in your brain? If yes, then I am going to give you something more than this. Now see to it, everyone. If I remove one oxygen from here, what I will get? If I am removing one oxygen from here, I will get H4P2O6. It will look like this: P double bond O, OH, OH, PP bond. There is PP bond, there was POP bond. See, the examiner will ask you, here was POP bond, here is PP linkage, PP linkage, PP linkage. But still the oxidation state is +4. So we will put ic. For +5 and +4 oxidation state, we will say ic acid. Otherwise, smaller oxidation state, we will say us. So something removed from it. One oxygen is less in this compound. So something is less. We will use the word hypo. So this is hypophosphoric acid. I think this much is clear to all of you. Now, if I am having one oxygen less than this, if I say H3PO3, H3PO3, how I am going to draw it? H3PO3, P double bond O, OH, OH, लेकिन one, I have to draw one hydrogen over here. See to it, everyone. I am going to place one hydrogen directly to this, and this hydrogen is responsible for making this compound to be reducing agent. If hydrogen is directly attached with phosphorus, this is responsible for making this to be reducing agent. Reducing agent. Now we will say orthophosphorus acid. Why phosphorus? Now see, 3 plus X minus 6 is equal to 0. So oxidation state is less. Less oxidation state means less than 4. If it is less than 4, we have to use word us. So this is orthophosphorus acid. Orthophosphorus acid. Another name for this compound is phosphonic acid. What is another name? Phosphonic acid. Remember that, very very important for examination. Examiner will definitely ask this, phosphonic acid. Now even one oxygen less than this, I will be having H3PO2. H3PO2. H3PO2 means P double bond O, H, H, OH. Now two reducing hydrogens are here. Very very good reducing agent. Very good reducing agent. Very very good reducing agent. Clear to all of you? Very very good reducing agent, and its name is phosphinic acid. Phosphinic acid. This is the general name of this compound. Otherwise I will say something less. So hypophosphorus acid. Why hypophosphorus acid? Because the oxidation state is only one. So I will say hypophosphorus acid. So this is the memory chart. This is the memory chart. If you like this memory chart, do let me know, because in the examination directly they will ask such type of question. And let me show you, this is given in your NCERT. This is given in NCERT. Let me show you where it is given. So see whether you are able to solve all the questions of NCERT or not. Let me show you. Just wait for a second. Just let me see to it. Wait for a second, then I will solve the questions. Okay, I got it. Finally I got it. See, sorry for little bit delay. Sorry for little bit delay. Kids, you can see it's given over there. See, everyone see to it. H3PO4 orthophosphoric acid. Orthophosphoric acid. It's given in NCERT. This is the data of NCERT. Orthophosphoric acid, pyro H4P2O7, pyrophosphoric acid, orthophosphorus acid, hypophosphorus acid. Now see, this is cyclic form of metaphosphoric acid, that is HPO3 whole thrice trimer of metaphosphoric acid, and this is polymer of HPO3 whole N, polymeric form. Kids, just do let me know in the chat section the memory chart which I have given to you is, are you able to understand it or not? Whatever the memory chart I have given to you, this is NCERT table, and this NCERT table you have to just keep in your brain, then only you can do all the questions of P block. Just do let me know, my kids. Now I am going to give you the memory chart for oxy acid of sulfur, but before that let me know that are you able to keep it in your brain or not? How is the energy after coming back? How to remember the structure? How to remember the structure? Let me tell you, don't worry. How to remember the structure? See, just focus on, everyone just focus on orthophosphoric acid. Orthophosphoric acid. See to it. Orthophosphoric acid. Kids, everyone see to it. Orthophosphoric acid. What I am writing, always do remember one thing. If the oxidation state is higher, for higher oxidation state means plus 5 and plus 4, we have to use the word ic acid. One thing is clear to your brain. For lower oxidation state, this was higher oxidation state. For higher oxidation state, we have to use ic, and for lower oxidation state, we have to use the word us. This thing is clear to all of you. Us acid. Now see to it. Orthophosphoric acid, H3PO4. This is the king. Like your Wassim sir, right? This is the king. Okay, H3PO4. Now phosphorus valency is like this, OH. Now how many replaceable? The basic, minimum basic required thing is this much. Means for a compound to be oxy acid, if a compound we are going to say oxy acid, what minimum thing is required? It must have like this. Rest of the things can be anything, but it should have bare minimum like this. This thing is required for a compound to be called as oxy acid. This is the compulsory part. Are you getting my point? This much is the compulsory part. If higher oxidation state, we will say ic, lower oxidation state, we will say us. Only these two things you have to keep it in your brain. Now let us find out the oxidation state. 3 into 1 plus x plus 4 oxygen and minus 2. How much you will get? X will come out plus 5. So which word I have used? Ic. And this was the general acid, so I have to call it orthophosphoric acid. Are you getting my point? Now see what I am going to say. Everyone see to it. If I take two molecules of it, and if I am going to remove water, see the structures, command on structures. Two molecules I am going to take, P double bond O, OH, OH, OH. If I am heating and removing water, the word must be used pyro. See to it, everyone. This water has been removed. See to it. Water has been removed. Now what I will get? I will get P double bond O, OH, OH, O, P double bond O, OH, OH. Heat means pyro word. Pyrometallurgy, pyro. We have to use word pyro. So this is pyro. Phosphorus, oxy acid is there. Now oxidation state is plus 5, plus 4, plus 3. See to it. H4P2O7. H4P2O7. Either you can calculate it like this. There are a number of ways of calculating oxidation state. See, I can use 4 into 1. 4 into 1 plus 2x minus 14 is equal to 0. So x will come out 5. Or I can use minus 2, so plus 2, minus 1, so plus 1, minus 1, so plus 1, minus 1, so plus 1. How much it is coming? You can see it is coming out plus 5. So pyro phosphoric acid And if only with 1 mole, this is the pyro. When to use the word pyro? Is it clear to all of you? If you are taking 2 moles of this, 2 molecules of it and removing water, 2 molecules by taking 2 molecules and removing water, you will get this. This much is clear. If you are getting this, just do let me know. Yes. Kids, once the concept clarity is there, once if you are able to understand the concept, show the thumbs up. Just show the thumbs up in the chat section. Otherwise, how I am going to, I won't be able to understand whether you are able to understand or not. At least I should get some sign of कि yes, kids are able to understand. Now see, with 2 molecules, if you are removing water, you will get pyro. You will get pyro. Pyro, phosphoric acid. Now see, if I heat, this was phosphorus acid. See, H3PO3. This is us. Why it is us? See to it. 3 into 1 plus x plus 3 into minus 2. This will become 0. So 3 plus x minus 6 is equal to 0. So x is equal to plus 3. So we have to use us. So its name is ortho phosphorus acid. Phosphorus acid. Now if I take 2 molecules of it, let me draw the structure. See, it is oxy acid. How to draw the structure? See everyone, I will write P double bond O and OH. This is the compulsory part. P double bond O and OH, this is the compulsory part. Are you getting my point? Kids, are you able to understand? This much is the compulsory part. Now how much is left? H3, 1 is already, let me write down 1H. How many oxygens left? 1. So I will write like this. Are you getting my point? So whatever the hydrogens are attached with the oxygen, these hydrogens are the basicity of this compound. So basicity is how much? Basicity is how much, kids? Basicity is 2. This hydrogen is not replaceable hydrogen, not acidic hydrogen. This is not acidic hydrogen. This hydrogen is responsible for reducing agent. So it's making the entity reducing agent. Making the entity as reducing agent. Kids, are you able to understand? Everyone, do let me know, are you able to understand? Now, if I remove water from this molecule, what I will get? Do let me know in the chat section. If I remove by taking 2 molecules of it, and if I remove water from it, by taking 2 molecules of it, and if I am removing water, by taking 2 molecules of it, and I am removing water, what I will call it? What I will call it, kids? Do let me know what I am going to call this compound. HOH. Now see, O, P double bond O, H, OH. Now this is, just do let me know what you are going to say. If you are saying this is, if you are saying this is pyro, if you are saying this is pyro, examiner will give you big 0. This is not pyro. Ask me why. This is wrong. It's not pyro. Ask me why it's not pyro. Everyone ask me why it's not pyro. You are going to get big 0. It's not pyro. It's not pyro. Ask me why. Ask me why. Kids, ask me why it's not pyro. Ask me in the chat section why it's not pyro, and this is the wrong structure of pyrophosphoric acid. Or is it correct? Is it wrong or it is correct? Do let me know. Do let me know it is right or wrong. It's not pyro I am writing, or it's pyro. Let's see. Option B, it's not pyro. Option A, it's pyro. It's pyro. It is wrong or right? Just do let me know this is right or wrong. 2 options are there. Is it pyro or is it not pyro? I want to see how much brain you are having. I am asking, it is pyro or it's not pyro. You will go for A, कि it's pyro, or you will go for B option, it's not pyro. Most of the students are saying B. So kids, here is the important thing, most important thing, that B is not the correct answer. Only A is the correct answer. It is pyro. It is pyro. That I wanted to ask you kids. It is pyro. This is correct structure. This is pyro. This is pyro. This is pyro. So we will go for B. It's the correct structure of pyro, and this question has been asked several times and most of the students get confused over here. See what structure, what planning, what concept we are supposed to apply. See, P double bond O, H, OH, O, P double bond O, OH, H. This is the true structure of pyrophosphorus acid. Now what NCERT says, see to it, what NCERT says. According to NCERT, PP and pH are not possible. PP bond and pH bond simultaneously, they are not possible. Both together these two bonds are not possible. P to P and P to H. If there is P to H, PP bond is not possible, but POP bond is possible. This is possible. Are you getting my point? If you see NCERT is writing that PP and pH are not possible together. Not possible together. Not possible together. But NCERT has never written that POP and pH are not possible together. So these two things are possible. So now if I draw from this pyrophosphorus acid, if I draw hypophosphorus acid, now that is not possible. See to it everyone, this is not possible. See, P double bond O, H, OH, O, P double bond O, H, OH. Now if I remove this oxygen and if I draw like this, see everyone, if I draw like this, P double bond O, H, OH, P double bond O, H, OH. Now there is problem. This is not possible. Not possible at all. Not possible at all. Why? Why this molecule is not possible? What's wrong in this? Kids, do let me know what's wrong in it. What's wrong in it? One kid is writing that pyro is having 7 oxygen. See, one is pyrophosphoric acid, one is pyrophosphorus acid. See to it, kids. This is pyrophosphorus acid, not pyrophosphoric acid. This is pyrophosphorus acid. One is pyrophosphorus acid, one is pyrophosphoric acid. This is pyrophosphorus acid. Now, why this structure is not possible? This is not possible. This is wrong. Exactly, it is wrong. Exactly, it is wrong. Why it is wrong? Do let me know. Exactly, it's wrong. It's wrong. It's wrong. What's the problem with this structure? Do let me know in the chat section, because it is having PP bond as well as pH bond. These together not possible. Together they are not possible. Together together PP and pH are not possible, so this is being the wrong structure. Is it clear to all of you now? Do let me know in the chat section. This compound is not possible, this doesn't exist. Is it clear to all of you? And it's given in your NCERT only. So how will you write hypophosphorus acid? How will you write hypophosphorus acid? So hypophosphorus acid, you have to write like this: P double bond O H H O H. So see, the compulsory part is over there. This was the compulsory part, this is over there, and this is known as hypophosphorus acid. I think now this point is very much clear. This is known as pyrophosphorus acid. So if this much is clear, then I am going to give you oxyacid of sulfur. Are you ready? If this point is clear, very much clear to all of you, then I am going to give you the oxyacid of sulfur. Do let me know in the chat section if you are able to understand all these points are clear to all of you, then yes. Now see, one more thing, let me tell you very clearly that phosphorus lies on this line. What is the minimum oxidation state of phosphorus? Minimum oxidation state of phosphorus, minimum oxidation state of phosphorus, that is -3. By taking 3 electrons, its octet will get complete, and the maximum oxidation state of phosphorus, maximum oxidation state is +5. So do remember one thing, in between these oxidation states, any oxidation state if phosphorus is having in between these two, means between minimum and maximum, any oxidation state in between, any oxidation state in between, phosphorus will show disproportionation. Phosphorus will show disproportionation. In which medium? In acidic and alkaline medium. Whether it is acidic medium or alkaline medium, it will show disproportionation. But if we talk about nitrogen, this was for phosphorus. If we talk about for nitrogen, so 1 to 4, nitrogen will show disproportionation. Only in acidic medium. This is the point to be noted, my lord. The first point about nitrogen will show disproportionation only in acidic medium when the oxidation state is 1 to 4, but phosphorus in any oxidation state like -2, -1, 0, +1, +2, +3, +4, whatever the oxidation state is given, when you are going to heat it, it will show disproportionation. Now I am going to tell you the most important thing, most important result on the basis of it. See how to do the question. If you are provided with H3PO3 and you are going to heat it, what will you get? Kids, what will you get if you are going to heat it? Now the oxidation state over here is 3 into 1 plus X plus 3 into -2, no charge on the compound, 0. So 3 plus X minus 6 is equal to 0. So X is equal to +3. So here the oxidation state is +3, or the medium can be acidic or basic. You will get the least oxidation state one, phosphine gas. This will get evolved as vortex rings. How the vortex rings are moving? See, it will go like this. Vortex rings. Phosphine gas, it has smell of rotten fish, Do remember, smell of rotten fish. This gas is being poisonous gas. This is the minimum oxidation state, plus you will get H3PO4, maximum oxidation state. Maximum oxidation state 1 you will get, and the minimum oxidation state 1 you got. Are you getting my point? This is very easy to recall it, very easy to understand it. This is -3 and this is +5. Same thing, if I heat H3PO2, I will get the same thing. See over here, this is H3PO2, and if I am going to heat it, what I will get? If I am going to heat it, heating in acidic medium, I will get minimum oxidation state, because see the oxidation state over here, 3 plus x minus 4 is equal to 0. So x is coming out to be +1. So it is going to give you phosphine gas PH3 plus H3PO4. H3PO4. That means minimum oxidation state -3 I have got, maximum oxidation state plus I have got. So minimum oxidation state I will get and maximum oxidation state I will get. So it is very easy. No need to cram inorganic chemistry. People used to say that it is a cramming part, inorganic having number of exceptional cases, but kids, are you able to understand? If you got it, if you got the approach, do let me know in the chat section. I can't see energy level in the chat section. I want to see that. Kids, my energy level is okay or my energy level is down? Do let me know. If my energy level is okay, then I want to see the same, because to every action there is equal and opposite reaction. I want to see that energy level. Kids, chat is moving very slowly, and this is not the way. This chat section is only the way of bonding in between me and you. These chats, do remember, these chats are only the way of communication, only the way of bonding in between me and you. And if the bonding is not proper, how you are able to understand? If you are getting the best, awesome, all the things, if you are able to understand, kids, do let me know. Do let me know, everyone. Very good. I can see. Now I am going to deal with oxyacid of sulfur. That I am going to give you as a gift. Okay, now see, everyone, see to it. But before that, let me give you the memory chart of, Okay, let me give you the memory chart of phosphine first. Mind map of phosphine. Everyone ready? Just do let me know, then only I am going to give you mind map of what I have written over here. Just let me know in the chat section what I have written over there. Yes, let me know. Mind map of phosphine. Do you know what is phosphine gas? This is phosphine, PH3. Very, very bad smelling, poisonous gas, colorless, poisonous, smell of what? Smell of rotten fish. Now how will you prepare it? Preparation. You know your captor. Captor, do you remember captor? So I am going to make this phosphine through captor. Hey Capto, please come. Capto, Ca3P2. Just do remember Capto, calcium phosphide, Capto. I'm going to make this phosphine from Capto. If Capto reacts with water, if Capto is going to react with water, what will you get? If Capto is undergoing hydrolysis, you will get phosphine minus calcium hydroxide. Capto. Now, if Capto is reacting with HCl, you will get phosphine gas, and what will eliminate out? Calcium chloride will eliminate out. Now, you can make this phosphine gas from P4 also. P4 plus NaOH plus water, you will get this phosphine gas. So, these are the three methods by which phosphine gas can be prepared. So, you will get phosphine gas, and this will undergo disproportionation reaction. If I tell you in detail, if I let you know in detail, then I will write it like this. See, everyone, see to it. I can write it like this: P4 plus NaOH plus water, you will get this. Now see, phosphorus is in 0 oxidation state. You got pH 3 minus 3 oxidation state, plus you will get NaH2PO2. What is it? What do you call it? What this compound is known as? Kids, what this compound is known as? This is known as SHP. I am HSP. This compound is known as SHP. This is really very important. How to write down its name? Do let me know what this compound is known as. H3PO2. What do you call it? H3PO2. Do let me know. H3PO2. This is known as hypophosphorus acid. Hypophosphorus acid. Now, whenever the us acid is going to form salt, we will write ite. See, whenever us acid is going to form salt, what will you write? You will write ite. Whenever ic acid is going to form salt, you will say 8. These 2 points you have to keep in your brain. Kids, these 2 points are really very important. You have to keep it in your brain. Whenever ic acid is going to form salt, you have to say 8, and whenever us acid is going to form salt, you will say ite. Now see to it everyone. This is us acid, and you have replaced one H. See, only one OH was there to be replaced. See, let me draw the structure of this acid. HOH. This H, acidic H, has been replaced by sodium. This was monobasic acid, and one H has been replaced. So the salt will be known as ite or 8. Ite. Sodium hypophosphite. Is it clear to all of you? Sodium hypophosphite. So these reagents will give you pH 3 plus this. Over here -3, and here the oxidation state of phosphorus you can see +1, +2, 3 and minus. So it will come out +1. It is +1. So P4 0 to -3, this is reduction, and 0 to +1, this is oxidation. Let me tell you. See this reaction, P4 plus NaOH plus water, what I am writing, it has given you pH 3. It has given you pH 3 plus NaH2PO2. See to it, Here the oxidation state is 0, from 0 to -3. What do you say? 0 to -3, and here 1 plus 2 plus x minus 4 is equal to 0. So x is equal to +1. So +1. What do you call it? See to it. This reaction is very, very important. We talk about the examination. This is reduction, and here the phosphorus has undergone oxidation. So this is just the redox reaction, and better to say disproportionation redox. Is it clear? Is it clear? Are you getting my point? Are you able to understand? Kids, are you able to understand? Are you able to understand? So what I was saying, what I was telling you, how can you prepare phosphine? How can you prepare phosphine? Do let me know. Let me check it out whether you are able to understand or not. How can you prepare phosphine? Do let me know. From Capto, Ca3P2. Capto, when reacts with water, you will get phosphine minus calcium hydroxide. Now second, when Capto reacts with HCl minus CaCl2, phosphine. And third way is when you react P4 with NaOH and water, you will get phosphine and minus NaH2PO2. These three reactions are given in NCERT. You can check your NCERT. This is given, this is given, and this is given. Now phosphine, this is very, very dangerous gas. Capto, remember Capto. Now when this phosphine reacts with water in presence of sunlight, water plus sunlight, so better to write down on the arrow, when this phosphine reacts with water plus sunlight, it will give you red phosphorus plus hydrogen gas. This is also given in NCERT, and many times this question has been asked. This is really very, very important question. Do remember, this is the most important thing. And when this phosphine gas reacts with CuSO4, now see, CuSO4, when it is going to react with CuSO4, it will form Cu3P2. When it is going to react with HgCl2, it will form Hg3P2. So these are the reactions, these are the preparation of phosphine gas, and the most important thing, whole signal, the signal which is given to the ships. See everyone see to it. Ships, you know ship, how ships are getting messages. Let me draw the ship. Ship. How we can send messages to the ships? How we can send message to the ship? Sending message, we have to use calcium phosphide Ca3P2 plus calcium carbide. Now this is known as Holmes signal. This is known as Holmes signal. Very, very important. Holmes signal. Very, very important. Given in NCERT. Now what they will do? Let us suppose we have taken drum with hole. Drum is taken with hole. Holes are over here. And what is filled inside it? Inside it, it's their calcium phosphide Ca3P2, your Capto plus calcium carbide. Now what they will do? When calcium carbide comes in contact with water, when calcium carbide comes in contact with water, what is going to happen, kids? What is going to happen? This will react and it will produce acetylene gas. It is going to produce acetylene gas. And when Cap2 is reacting with water, CH3P2 is reacting with water, it will give you phosphine gas, and this phosphine gas produces smoke. The phosphine gas produces smoke, kids. Phosphine gas produces vortex ring, smoke, and acetylene burns, it gives fire. So fire plus smoke is produced. Fire plus smoke gives a signal to the ship that yes, something is there. Is it clear to all of you? Are you able to understand, kids? How is the diagram I have drawn? Just to let me know in the chat section. Are you able to understand the whole signal, the diagram, this Titanic ship I have drawn? I can't see that energy level in your chat section. What's going on? Kids, everyone do let me know. Now, each and everything I have told you. Now let's move towards oxyacid of sulfur. Oxyacid of sulfur. Oxyacid of sulfur. Oxyacid of sulfur. Everyone ready? Oxyacid of sulfur. So what is required? The minimum requirement is S double bond O and OH. This is the compulsory part. Agreed, everyone? This is the compulsory part, and the valency of sulfur is 1, 2, 3, 4, 5 and 6. Now see, everyone, I am going to tell you each and everything about the oxyacid of sulfur. Now see, we know this compound very well. S double bond O, OH. What do you call it? Just do let me know, what do you call it? H2SO4. Either we can call it sulfuric acid because it is in higher oxidation state. Higher oxidation state means ic acid, sulfuric acid. Now this much is very much clear to all of you. This is being sulfuric acid 1, 2. So how many replaceable, maximum number of replaceable H plus ions they are attached with oxygen? So its basicity is 2 and factor is 2. Basicity is 2 and factor is 2, right? Is it clear? Is this much clear to all of you? First part is, basic part is clear to all of you. Higher oxidation state we are going to say ic acid, and in lower oxidation state we will say us acid. Kids, are you able to understand this much compulsory part? Then I can move ahead. If this much part is clear to all of you, do let me know in the chat section. Yes, now see. If I take two molecules of H2SO4, this is H2SO4, one more H2SO4, 2 moles of H2SO4 if I add them, I will get H4S2O8, and if I remove water from here, if I remove water from this H2O, if I am going to remove from this, what I will get? Definitely I am going to get, yes, what I am going to get, kids? H2S2O7, right? This will be known as pyrosulfuric acid. Pyrosulfuric acid. This is really very, very important compound. Now, if I draw the structure of this, if I draw the structure of it, I will get S double bond O, OH, OH. Just a second, kids, just a second. And just guess who is there.
Who's there?
Yes. Let me see if you are able to understand. See whose 5 fingers are there along with one thumb. Just try to understand. Just try to recall. Kids, just try to recall. Oh, one. Another one is Capto. 2 are writing Capto. 1 is writing Wassim sir. Another was Fire Wassim sir. Font got changed. Hey, let me see.
Yo guys, what's up? Is the Joe still high? Yes? Quickly, yaar. Let me know in the chats. Quickly. Someone is saying Ambika, I'm his friend. Wow.
Great.
Someone is saying beard boy.
Great bonding is going
on. Do I look like a boy? Huh? Nice, yaar. Loving the Josh which you guys are keeping. So, sir, I'm done making 1,000 questions.
Oh, yes.
Right. So, tomorrow's marathon, guys, do not forget to, right?
Better to say that is rank boosting
marathon. Now I'm done with the questions. Like everything is done for the tomorrow session. It was so hectic to select the 1,000 questions, honestly. Right. So, the session is going to start at 11 a.m. tomorrow. You have to join that session. That's going to be the game changer for all the students. Okay. And what is sir teaching you? H2S2O7. What do you call this? Do we call this as Marshall's acid or oleum? Tell me in the chats. What do we call this as? Marshall's acid or oleum? H2S2O7. Quickly, yaar. You have to be really quick. What do we call this as? Is it oleum or Marshall's acid? Someone is saying beard man. Wow. I want its answer, yaar. Quickly. Absolutely, it's oleum. Is there any SOS linkage here? Yes or no? Is there any SOS linkage? आपने पढ़ा है अभी ये?
अभी पढ़ा नहीं, बनाने जा रहा हूँ.
Okay.
SOS linkage. I am going to teach.
अच्छा. Let me ask them first. Is there any SOS linkage here?
Oh, great people. They have started saying oleum. Great. Oh.
Wonderful. It's not Caro's acid. Caro's acid is H2SO5. पेन दे दो सर एक बार.
Wow, these
थोड़ा
people
मैं
are
बता
really
दूं.
great. Really
थोड़ा
great.
मैं बता दूं. It's a special compound, by the way. Question can come out of this. Okay, do remember this properly. Like whatever sir is teaching, everything is really very important, because all the concepts which sir is teaching, these are very crisp, these are very precise to the point, and the questions directly indirectly will be from these concepts only. Yeah, absolutely. When you talk about this H2S2O7, so it's like this, right? शॉर्ट में बना रहा हूं मैं.
Someone is saying Bato sir.
Huh?
Someone is saying Bato sir.
This is your H2, S2 and 7O. There is one SOS linkage. It can be asked. Number of SOS linkage here is equal to 1. Right? Okay. Somebody just tell me what is the oxidation state of the sulfur which I'm going to mark here. What is the oxidation state of this particular sulfur here? Quickly in the charts. It's double bond O, single bond O. The oxidation state of this sulfur is +6. This sulfur is also in +6 oxidation state, and the average oxidation state of sulfur here is also what? It's going to be +6 only. Correct? Someone was asking about Caro's acid. Caro's acid is H2SO5. H2SO5 is your Caro's acid. Okay? And if you talk about the H2SO5 structure, it is S double bond O, oxygen attached with hydrogen. Then there's a peroxide linkage here, and it's hydrogen. This is H2SO5.
Wow, great.
Yeah. And what
really
about the
awesome.
oxidation state here? It's also +6. Perfect.
Really awesome.
Marshall's acid is H2S2O8. H2S2O8 is your Marshall's acid. And when you talk about its structure, it's like this. S O, O, this is S, double bond O, oxygen attached with hydrogen. This is double bond O, oxygen attached with hydrogen. Here you have got SOOS linkage, and this is the peroxide linkage also here, oxygen, single bond oxygen, right?
And one more thing. From this, we have combined two molecules of sulfur. We got this, and it has formed the peroxide linkage. So peroxy disulfuric acid.
लिख दो.
Peroxy disulfuric acid also. We can call it peroxy disulfuric acid. Disulfuric acid.
All these compounds are really very important. Okay, question
Peroxy.
will be for sure asked about these structures.
And if I add one oxygen like that, what Wassim sir has told you, if I do the oxidation of it, and if I am writing one oxygen over here, see, S double bond O, OH, this will be H2SO5, Carros acid, or we can say peroxy monosulfuric acid. Peroxy.
This sir is talking about this H2SO5.
Yeah, that one. Same.
I had made it already.
Okay.
Asha, one more question. If it's about structures, sir, I'll take 2 minutes.
Yeah.
I'll see whether they remember or not.
It all yours, sir.
Thank you so much. Okay. What about this one? CrO5. Tell me the structure, peroxide linkage, everything about CrO5, CrO6, Br3O8, and C3O2. These are some special compounds, and similarly you have got BaSCN whole twice. These are some special compounds from which questions can be asked. CaOCl2 as well.
Yes.
Do remember their structures. Let me make their structures once quickly.
One question. One is having plus which oxidation state?
Which one?
No, it's not over here. It's not over here.
Let me make a quick structure of all these. This CrO5, do remember, it has got a butterfly structure. And do remember its color as well. It's deep blue in color. This was once asked in your JEE mains. What is the color of CrO5, right? So this is Cr double bond O, oxygen peroxide linkage, oxygen peroxide linkage. This is the structure of your CrO5. When you talk about CrO6, this is Cr, and this is oxygen peroxide, oxygen peroxide, oxygen peroxide. This is your CrO6. Do you remember this? When you talk about Br3O8, this is Br, single bond Br, single bond Br. Now you have got 8 oxygen atoms, right? 3 here, double bond O. This is the structure of your Br3O8. Okay. Then when you talk about C3O2, right? This is your C3O2 structure. Do you remember this as well? Then when you talk about BaSCN whole twice, this is Ba, this is S, C triple bond N, this is S, this is C, this is triple bond N. This is BaSCN whole twice. Then when you talk about the bleaching powder, CaOCl2, this is Ca, this is OCl, and this is Cl. All these structures are again equally important, so have an eye on these structures as well, okay? Perfect? Sir, le lo.
Along with this Br3O8, K3CrO8. That is also confusing.
Yeah, K3CrO8, you can also...
K3CrO8.
Let me show you that as well. This is Cr. This is your K3CrO8. Do remember this particular structure as well. This is again equally important. And the oxidation state of chromium here is +5. There are 1, 2, 3 and 4. 4 peroxide linkages. Number of peroxide linkages is 4. And if they ask you how many oxygen atoms are there with -1 oxidation state, all the 8 oxygen atoms are there with -1 oxidation
And
state.
this compound is really very important, because whenever the peroxide linkage is given over there and the oxidation state reaches, means it goes more than 6, we used to say it is 6. But this is the compound which is not having +6 oxidation state. This is having +5 oxidation. That's why it is very important.
Yeah. So all these structures are very important. So have a proper eye on these structures. Please do that. One more structure which is also equally important. The question has been asked from this structure as well 2 times in JEE mains. So probability of the question to be asked in NEET is also very much. Na2S4O6. Na2S4O6. Question has been asked out of this. This is S, single bond S, single bond S, double bond O, double bond O, here double bond O, and this oxygen attached with sodium here, and this is oxygen attached with sodium. What is the best part here? The oxidation state of this sulfur is +5. Here it is 0. Here it is again 0. Here it is +5. And if you want to calculate the average oxidation state of sulfur, here, one oxygen has got +5, another one 0, third one 0, and fourth one +5 divided by number of sulfur atoms 4. So the average oxidation state of sulfur here comes out to be +2.5. So have an eye on this structure as well. See why I'm telling you have an eye? The question in JEE was like this. The correct set of oxidation state of sulfur in Na2S4O6 is option A, which I'm writing, +5, 0, 0, +5. This was the answer of the question, which I mentioned over here categorically, okay? Right? So do remember this particular one as well. Correct? Sir, P4O6, P4O10 structure बता दिया?
No, right now, I haven't told them.
Structure of P4O6, P4O10 is also important, huh? So have an eye on that as well. Perfect, sir. You continue now. Guys, again, I'm telling you, I'm very much busy with the tomorrow session. So, sir is taking care of the session very nicely and you guys are equally engaged in the session. That's wonderful, right? Do not forget to attend the tomorrow session. That's at 11. Those are going to be the top 1000 questions of your PCB. But I'll be starting the session with chemistry, then bio, and then we'll be doing physics as well.
Sir, but you have to wait for some time. Let me tell them the structure of P4O10 in front of you only. I want to do that.
I'll do that quickly.
No, let me do it. You just let me whether it's right or wrong. No, it's. I'm going to draw the structure of first P2O3. That is, yes, dimer of P2O3, P4O6. See. P2O3 dimerize will get P4O6. Now see the structure of this. East P, in the west P, north P, south P. Now see POP, POP, and POP, and POP. Now POP and POP. So I think how many oxygens I have drawn?
You have drawn 6 oxygens.
Okay, so we are having lone pairs.
Every phosphorus has got one lone pair here.
So question may be asked, how many POP linkages are there? How many lone pairs? Total number of lone pairs. So total number of lone pairs. Total.
They can do it on their own now, I think. First question which can be asked from this structure is, how many POP linkages are there? Number 1. Number 2, what is the hybridization of this particular phosphorus? This can be one more question. Similarly, how many total lone pairs are present in this particular compound? These can be different sets of questions which can be asked. This is your P4O6. Now, if you want to make P4O10, so let's say this phosphorus here. If you want to make P4O10, these are 4 phosphorus atoms, right? Oxygen, oxygen in between, oxygen in between, oxygen in between, right? Now, join these two, POP linkage, join these two, POP linkage. Every phosphorus attach a double bond with oxygen. Attach a double bond with oxygen, right? So this is the structure of your what? This is the structure of your P4O10. When I wrote JEE mains long back, this was the question asked, right? Structure of P4O10. So P4O10, P4O6, these are very, 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 very important compounds. You have to keep an eye on these as well. Okay. Well, if you ask me about the hybridization of this particular phosphorus, have a look. 1 sigma, 2 sigma, 3 sigma. 3 sigma and 1 lone pair. So steric number is 4. If steric number is 4, its hybridization is going to be what? It's going to be sp3. Well, if you look at this particular phosphorus, 1 sigma, 2 sigma, 3 sigma and 4 sigma. So 4 sigma, 0 lone pair. 4 sigma plus 0 lone pair. Steric number again is what? 4. So hybridization is again is what? sp3.
Oxidation state, sir.
निकाल लो sir.
How to find it out? I don't know.
Done, you do it.
How to do it?
Achha, I'll take a leave now. You guys carry on, sir. I have to take the
Kids.
questions.
Okay.
Okay, you
Thank
guys
you.
carry on.
Thank you, sir. Thank you, sir. Now, kids, you can find out the oxidation
See you
state.
tomorrow, guys. Okay. See you tomorrow at 11 a.m. sharp. 11 a.m. sharp tomorrow. I want everyone to attend the 1,000 question marathon, which is going to be the rank booster, which is going to be the rank predictor session for all the ones. Okay. Take care.
Just show the thumbs up what sir is saying. For that, to every action there must be equal and opposite reaction. Just show the thumbs up, everyone.
Yes, they are super duper excited about that. That's wonderful, guys. And do click on notify me at the same time on that particular session. I want everyone to join that. Okay. Sir, इनको बोराजीन का stock.
I have already told them. I think he was absent at that time.
Okay.
You can see the means what
I mean,
recording.
if you drag the video a little
Yeah.
back, you can find the borazine structure. Your inorganic benzene.
Yeah. See,
Perfect, guys. Wonderful. Wonderful. Great. Love the Josh. See you tomorrow at 11. Take care. God bless you all. Love you all.
Okay, sir. So kids, we were dealing with oxy acid of sulfur. Now let me tell you, we have drawn sulfuric acid. This was H2SO4. This was H2SO4, sulfuric acid, and when we have eliminated out water, we eliminated out water from 2 moles. 2 moles, we took 2 moles and we eliminated out water. We got S double bond O, OH and O, S double bond O, and OH. So what we got actually? We got H2, S2, O, 1, 2, 3, 4, 5, 6, 7. This is also known as fuming H2SO4. Fuming H2SO4, or we can call it oleum, or we can call it pyrosulfuric acid. Pyrosulfuric acid. I think this point is very much clear to all of you. Now, the most important thing, if we remove one oxygen, and we put one sulfur, sulfur in place of oxygen, what do you call it? This is H2SO4, then it will become H2S2O3. This will be known as thiosulfuric acid. Now, question arises, which is the correct structure of thiosulfuric acid? See, which one is the correct structure of thiosulfuric acid? What I have done, what I did, H2SO4, and I replaced sulfur, removed oxygen, I got H2S2O3. Now see, which one is correct? S double bond S, OH, let us suppose we call it A, and if we take S double bond O, SH and OH, this is B. Which one is the correct structure of thiosulfuric acid? First one or second one? Which is correct? Which one is thiosulfuric acid? Which one is thiosulfuric acid? Do let me know. Kids. This is the most important question, rank deciding question. If your aim is AIIMS Delhi, to go AIIMS Delhi, then you should know this structure. Which one is the correct structure, A or B? Which one is thiosulfuric acid? Here I have placed oxygen in place of this oxygen. Here I have placed sulfur in place of this oxygen. Which one is correct? Yes, I want to see. Do let me know, everyone. Everyone is saying A. Kids, both are correct. This is also. Both are being correct. Both are thiosulfuric acid. Should I prove it? Should I prove it? See to it. How? See everyone. Everyone see to it. If I write it like this, S double bond O and OH and SH. See to it. This hydrogen is acidic. This hydrogen is acidic. Acidic hydrogen. So acidic hydrogen will go away. Acidic hydrogen will go away. This will carry negative charge. This is having positive charge. Once the proton has been eliminated out, you will get S negative, S double bond O and OH. This will do resonance. It will try to come at this position and this pi bond will shift over there. Now what do you get? You will get resonating structure like this. S double bond S, O negative, double bond O and OH. Now that proton, the proton which has been eliminated out, this proton is in equilibrium and this proton will come at this position. It will form the bond. What do you get? What you will get? You will get SOH, double bond O, OH and double bond S. So this was the A and this is B. This is being B. Once again this proton will eliminated out and it will come at this position. So the A and B form will remain in equilibrium. Is this point clear to all of you? A and B will remain in equilibrium. Kids, do let me know, are you able to understand? Do let me know. Both are the correct structure of thiosulfuric acid. Is it clear to all of you? Hey kids, do let me know if you got it. Do let me know, everyone, you got it. Both are the correct structures. Now let's move towards, say, the most toughest part. If I say this is white phosphorus, mind map, see. If I say this is white phosphorus, most confusing part, I am going to deal with most confusing part. Most confusing part. See to it, everyone. Focus over here. Most confusing part. P4, white phosphorus. Now, if I heat this white phosphorus, heating this white phosphorus for several days, in an inert atmosphere, what I will get? Do let me know, because this is the most important question and examiner is going to ask this question. So definitely I will get red phosphorus. Non-poisonous. Red phosphorus is meaning non-poisonous, and that was poisonous. This is your poisonous phosphorus. It shows chemiluminescence. This doesn't glow. No glow. It's not going to glow. Red phosphorus. Now if I heat red phosphorus, what I'm going to get? If I heat red phosphorus, this was the heating at 573 Kelvin. This was the heating at 573 Kelvin, and here I am going to heat at 873 Kelvin. What I will get? I will get alpha black phosphorus. But if I heat this white phosphorus, heating at low temperature, heating just at 473 Kelvin plus atmosphere means pressure, atmosphere pressure, I will get beta black phosphorus, beta black phosphorus. So this is the important point, that alpha black phosphorus we are going to get from red phosphorus. Alpha black is from red phosphorus and beta black directly from white phosphorus. This is the most important thing the examiner can definitely ask. Is it clear? Is it clear to all of you? Now see, I am going to give you the best important thing, most important thing I am going to give you about, yes, nitrogen, preparation of nitrogen oxide. See everyone, preparation of nitrogen oxide. Preparation of nitrogen oxide. Preparation of oxides of nitrogen. See, everyone see to it. See everyone, if I heat ammonium nitrate NH4NO3, do let me know which oxide I will get. How many oxides we have to deal with? See, how many oxides we have to deal with? NO, 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 NO. How many are they? 1, 2, 3, 4, 5, 6. All they are given in NCERT. See everyone. Everyone see to it. N2, 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 N2. Now see. O1, O2, O3, O4, O4, O5. Now this we can write N2O. This we can write NO. This we can write N2O3. That is NO plus NO2. This we can write simply NO, and this we can write dimer N2O4. It's NO2 not E, and it's N2O5. Now let's see the most important thing, that these two are neutral oxide, neutral oxides. Rest of all others are acidic oxides, acidic oxides. Is this point clear to all of you? First of all, just to let me know, is this much is clear to all of you? If this is clear to all of you, then I am going to tell you the preparation of these oxides. Everyone ready? Are you ready? Just do let me know. First of all, if you got this thing, then I am going to tell you the preparation of these oxides. I will tell you the preparation of these oxide. And one more thing, let me tell you over here only this is colored. This is known as, the color of this NO2 is brown, and this N2O3, because it is also having NO2. What is the color? What is the color of this? This is somewhat, you can say, blue colored. Rest of all others are colorless. This is colorless, colorless gas. This is colorless, colorless. This is colorless. This is also colorless. Now let me see the preparation of these oxides, these 6 oxides, because it is given in NCERT. How many of you want to remember how they are prepared? Because one table in an NCERT is given. One, yeah, very good. One table on the left hand page in your NCERT is given about the oxides of nitrogen preparation. Do let me know in the chat section how many of you want to get command on that. Then only I am going to tell you. Very good, very good. I want to see the energy level in the chat section. Then only I am going to give you. Everyone, I want to see the energy level. Now see, if I heat ammonium nitrate NH4NO3, I must have told you the trick. If you heat ammonium nitrate, what you are going to get? If you heat ammonium nitrate, any sort of ammonium you are going to heat, what you will get? Remove maximum of water. How many waters can be removed? How many maximum? Just remove maximum molecules of water. Maximum molecules of water. Yes. How many maximum molecules of water can you remove? You can remove 2H2O. Twice of H2O. 2H2O. What is left? Twice of H2O. Then N2O. You got N2O. You got this oxide. First preparation is completed. Now let's see the second preparation. See to it. Second preparation. Everyone see to it. If I treat NaONO, everyone say nano. No. Trick is no, nano. What is the trick? Trick is no, nano. Nano. So which gas we are going to get from here? FeSO4, H2SO4. Definitely we are going to get NO gas. We got NO. No, nano. What is the trick? No, nano. Clear to all of you? Two preparations are clear to all of you. You got two preparations. Nano. No, nano. No gas. NO gas you will get from nano. Nano. NaNO2. Sodium nitrite. NaNO2. Now third preparation I am going to tell you. Third preparation, see to it everyone. Third preparation. So third gas is NO2 gas. All metal nitrates. Remember that universal truth. All metal nitrates on heating and all metal nitrates from calcium to copper in the electrochemical series. You know electrochemical series? On heating will produce metal oxide plus naughty gas. This is naughty gas. See, lead nitrate, for example, lead nitrate on heating it's going to produce lead oxide plus NO2 plus O2. So this is the preparation of NO2 gas. Everyone got it? Is this clear? This preparation is clear. Now see the fourth preparation. See to it everyone. The fourth preparation. See to it everyone. Fourth preparation. Now if I react NO and NO2, what I will get? I will get N2O3. It's very simple. Now fifth, if I dimerize or cool down it, this on low temperature, at low temperature it dimerizes, it will give you N2O4, and at high temperature it will come back, right? Now the last one, last but not the least, N2O5. See, HNO3 plus HNO3, and we know that P4O10 is having high affinity for water, very strong affinity for water. This has very strong affinity for water. This is that much dehydrating agent that it can even eliminate out water from H2SO4. It can, dimer means doubling of it. Now if I combine these two, what I will get? What I am going to get? See, H2 N2O6, and if I remove water from it, what I will get? Do let me know, everyone, if you are able to understand what I will get if I remove water from it. I will get no H, N2O5, N2O5. So N2O5 is nothing. N2O5 is the anhydride of nitric acid. This question has been asked number of times. This question has been asked number of times in your NEET examination, AIMS examination. N2O5 is an anhydride of nitric acid. This is an anhydride of nitric acid. I think all oxides I have told you. No oxide is left. I have told you all the oxides. If you are able to understand, do let me know. Yes, show me the thumbs up. Then I am going to tell you the most important thing about halogens and then zero group. I will take halogens and zero group both. Everyone, now see. Everyone see to it. Halogens, the most important thing about halogens, the most important thing about halogens is, see, the first thing, electron gain enthalpy. Is this the correct word? No. If I say electron gain enthalpy, this is not the correct word. So what I am supposed to say? I have to use negative electron gain enthalpy. Negative electron gain enthalpy of Cl is maximum. Do remember, this is the most important, most frequently asked question. But remember, point to be noted, my lord, negative electron gain enthalpy word is given over there. So see why, if I say for fluorine, it's minus 333 kilojoule per mole. No need to remember the values. Just try to understand what I am writing. For chlorine, it's minus 349 kilojoule per mole. Now for bromine, it is somewhat minus 325. For iodine, it is somewhat minus 298 kilojoule per mole. What I am saying, no need to cram these values. Just remember that negative electron gain enthalpy of chlorine is being maximum. This is being maximum. Who is most electronegative? Although fluorine is most electronegative, but then also negative electron gain enthalpy of chlorine is maximum. So what I can write? I can write, if anyone is asking question, who is most electronegative among the halogens? Most electronegative element, yes, most electronegative element is fluorine. Its electronegativity is 4.00. But if somebody is asking element with maximum negative electron gain enthalpy, then what's the answer, kids? What is the answer? Then the answer is chlorine. Is it clear to all of you? Is these 2 points are clear to all of you? Are you getting these 2 points? Everyone getting these 2 points? Now, another question arises. Best reducing agent. Who is the best reducing agent? Fluorine, chlorine, bromine, iodine. Fluorine, chlorine, bromine, iodine. What's your answer? So definitely the answer is fluorine. So examiner can ask on how many factors. It depends that who is going to be the best reducing agent. Oh, not reducing agent. It's not the reducing agent. It will gain electron. It is being oxidizing agent. It's not reducing agent. It is being oxidizing agent. So oxidizing agents undergoes reduction. They undergo reduction. They undergo reduction. They undergoes reduction. So this is oxidizing agent, not the reducing agent. Everyone got it? Everyone got it? Be aware of it. So these are, this fluorine is best oxidizing agent. Oxidizing agent. So its standard reduction potential value will be positive. Standard reduction potential value will be positive. Now see, how many factors are going to decide? It depends on three factors. Three factors. What are those three factors on which? Three factors. One is bond dissociation energy. Second is being hydration enthalpy. Hydration enthalpy. And third is, yes, do let me know, after hydration enthalpy, negative electron gain enthalpy. These are the three factors. Negative electron gain enthalpy. So kids, fluorine doesn't have maximum negative electron gain enthalpy. Then what are the factors which are responsible for making it to be the best oxidizing agent? Examiner can definitely, the examiner can ask a question that bond dissociation energy or the hydration enthalpy or negative electron gain enthalpy, out of these three factors, which factor or which factors are making fluorine to be the best oxidizing agent? Kids, I want to know the answer from your side. Yes, do let me know. Let me first of all write down the bond dissociation energy. Bond dissociation energy order. Bond dissociation energy order. This is very, very important. Number of times this question has been asked. Very, very important. Bond dissociation energy order. So do remember, see, I am going to write Cl2, Br2, F2, I2. The trick for it, see, where is fluorine? Fluorine is on the third number. So let me tell you the trick. Let me tell you the trick. First of all, let me explain it. This chlorine has maximum, this is having maximum bond dissociation energy, and this is having least bond dissociation energy. So the trick is capto bro. Trick is capto bro, Florida to India. Florida to India. This is the trick I made for capto bro, Florida to India. So remember that this is really very, very important. They can directly ask the question because it is given in the table. That table is given in NCERT. What is the trick? Everyone do let me know if you are able to understand. Capto bro, Florida to India. How's the trick? Kids, you are not increasing my energy level. This is not fair. This is not fair. I am doing this much, but you are not increasing my energy. Capto bro, Florida to India. So see, fluorine is lying over here, white is lying over there, and what is making it to be on that position? See, first of all, let me know capto bro, Florida to India. Capto bro, Florida to India. So awesome trick I am giving you, but you are not showing me the thumbs up in the chat section. Capto bro, Florida to India. Now see everyone. So who is making the fluorine to be the best reducing agent? What two factors are in favor of, this is given in NCERT corner. What I am saying, NCERT corner, this is given the line in your NCERT corner. What two factors are responsible for making fluorine to be best oxidizing agent? Yes. What are the two factors which are in favor of this? So first of all, the most important factor is, the most dominating factor is, yes, everyone do let me know. If you are energetic, do let me know in the chat section what is the most dominating factor which is in favor of fluorine. Then only you are going to kill the exam. Then only you are going to get the best hydration enthalpy. Very good, Nilash, very good. First factor is hydration enthalpy. Because of very small size, hydration enthalpy in its favor. Hydration enthalpy because fluorine is very small. Very small. So water loves fluorine. So this is near about, this energy is minus 513 kilojoule per mole, and that is being maximum hydrated. Maximum hydrated means most exothermic reaction. That means delta H is negative, that is maximum exothermic. First factor. Second factor is very less bond dissociation energy. This is the second factor. Very less bond dissociation energy. So this question can be asked as assertion reasoning. Or simply they can ask this question in any way. They can ask this question. This question can be asked as assertion reasoning. Is this clear to all of you? Now, the point to be noted, why chlorine is having maximum electron gain enthalpy. See everyone, see to it. If I say this is being fluorine, and if I say this is being chlorine, fluorine size is small. This is small in size and this is too big in size, right? Let me say this is ant, and this is elephant. This is being your ant, this is your being elephant. Now fluorine's electronegativity you can say hungerness. Electronegativity is maximum. Electronegativity you can say hungry. Fluorine is too much hungry. Hungerness. Electronegativity is hungerness, and this is having less hunger. It's less hunger, right? Now see, this ant has not eaten anything from last 2 days. and this elephant did breakfast in the morning only. Now, in front of both of these, they have seen one pizza, 2 kg pizza, 2 kg pizza. In front of ant also 2 kg pizza was there. Now, who is going to eat more? Ant or elephant? Do let me know in the comment section who is going to eat more. This ant will eat more or the elephant will eat more. Elephant have had his breakfast in the morning only, but ant has not eaten anything from last 2 days. Ant has not eaten anything from last 2 days. This elephant have had his breakfast in the morning only, and in front to both of them 2 kg pizza is allowed. Ant will eat more. Oh my God. One kid is writing ant, you know ant. You see the picture of ant, little bit, very small. Ant is very small. Ant is having tendency to eat maximum, but ant can't eat 2 kg pizza. Ant is very small in size, will eat only a little much, can't eat too much. Due to very small in size, very small in size, can't eat too much, can't eat too much. This will eat too much. Elephant will eat too much. Now, what is the meaning of this in science? One thing is very much clear. Even though elephant have had his breakfast in the morning, but then also elephant will eat too much because this elephant size is too much. Now see what does it mean with respect to science? With respect to science, fluorine is having too much tendency, but very small size due to very small size, inter-electronic repulsion is too much, so can't gain electron easily, am I right? So can't gain extra electron easily, and this reaction is being exothermic reaction. F2 plus 2 electrons gives twice of F negative, so delta H is being negative when it is not going to take electron easily, so it is going to take electron with very small speed, or it is not having tendency to accept electron. On the other hand, if we talk about chlorine, so the size of chlorine is big. Due to big size, and even it is having vacant what? It is having vacant 3D orbital. There is no 2D. We know that there is no 2D. So chlorine, due to big size, can accept electron, can accept extra electron very easily, very easily. I hope this point is very much clear to all of you. So if we talk about electron gain enthalpy, then chlorine is having maximum electron gain enthalpy, negative electron gain enthalpy of chlorine is maximum, and if we talk about electronegativity, then fluorine's electronegativity is maximum. Is this point clear to all of you? Now see to it. Then we will deal with number of MCQs. We are going to deal with number of MCQs. let me tell you the most important thing about halogens. See to it, everyone. Yeah, this is rank deciding question. Yeah, this question is really very important. Now see, everyone, oxy acids of halogen, oxy acids of halogen, oxy acids of halogens. Do remember one thing, the name is very important. Hypohalous, halous, halic, perhalic. How many names? How many names I have written? Yes, do let me know. Hypohalous, halous, halic, perhalic. 4 names I have written. Everyone see to it. Hypohalous, halous, halic, perhalic. Now what are they? HOX, H, XO2, HX, O3, HX, O4. This is the maximum oxidation state of halogen plus 7. So it can't be more than that. Here it is 5. Here it is 3. Here it is X is having, let me tell you whether it's fluorine or what, right? Now see to it, everyone. See to it, everyone. HOF. Nothing possible, not possible. Even HOF, in HOF, fluorine has got negative, so this has got positive, not stable at room temperature. Not stable at room temperature, right? Not stable at room temperature. So this is not stable at room temperature. That means oxy acid of fluorine, only one fluorine, hypofluorous acid, but even that is not stable at room temperature. Now see, HOCl, HClO2, HClO3, HClO4, all 4 are possible. All 4 are possible. What are the name? Can you write down the name? Hypochlorous acid, chlorous acid, hypochlorous acid, chlorous acid, chloric acid, perchloric acid. Now how to learn the name? Ferrous, ferric. You know ferrous, ferric, just like ferrous, chlorous, ferric, chloric. Do remember, just keep it in your brain. Correlate with ferrous and ferric. Just like ferrous, we call it ferrous. We call it ferrous. So we will call it, yes, we will call it chlorous, chlorous, chlorous acid. We call it ferric, Fe3 plus. So chloric, chloric. Once these 2 names are clear, now something is less. Hypochlorous, hypochlorous. Now it is having something more. Perchloric, perchloric. Is it clear to all of you? Now if I talk about HOBr, HOBr, there is nothing. HBrO3, HBrO4. HOI, there is nothing. HiO3, HiO4. Now, the most important property of halogens, I am going to ask you one question and you have to answer it. That is the thing which examiner is going to ask again and again. See to it. Everyone see to it. See to it. If I ask you the most important question which has been asked number of times in AIMS or IITJEE, which reactions are possible? Which reactions are feasible? Which reactions are feasible? Which reactions are feasible? That is totally logic based question. Totally logic based question, and try to answer it. First one is KCl plus I2. Second, KCl ClO3 plus I2. Third, Ki plus Cl2. Fourth option is KiO3 plus Cl2. Just try to find out which reactions are possible, which are not possible. I am waiting for your answer. No need to cram. This is just logic based question. How many reactions are possible? Reactions 1, 2, 3, 4. 1, 2, 3, 4. Out of 4, how many reactions are possible? Do let me know the answer. I want to see how much knowledge you people are having. Yes, let me see to it. Let me check it out. Is there anyone or number of students are there who can answer this question? Is there anyone who's going to answer this question? Let me see to it. How many of you can give the answer? Whose answer is going to be correct? Let me check it out. Whose answer is going to be correct? Which reactions are feasible? Feasible means possible. Feasible means possible. Feasible means possible. Possible. So, yeah, this question is totally logic based question. You can't cram it. You can't do the rectification of it. This is totally logic based question. If you have knowledge, having knowledge can solve. Without knowledge you can't solve it. Let me tell you the answer. Which reactions are possible? This is not possible. This is possible. This is possible. This is not possible. Now, I don't think anyone has given this answer 2 and 3. I don't think. Is there anyone? Could you please let me know, is there anyone who has given the correct answer, whose answer is being correct? If your answer is correct, you can show thumbs up, or if your answer is wrong, you can show thumbs down. Now, how many of you want to understand? How many of you want to understand the logic behind it? Yes, do let me know how many of you want to understand the logic behind it. Just do let me know. How many of you want to understand the logic behind it? See. Okay, see to it. Everyone see to it. If I say in a forest, there was one potassium. And if I say potassium was always saying, take my electron, I have got one electron, just take my electron. There was, what options I have given you? I have given you chlorine and iodine. If here is chlorine and here is iodine, who is going to snatch electron of potassium? Out of these two, there is only one potassium, one potassium atom, one K atom, and in the jungle there is chlorine as well as iodine. Who is going to snatch electron of potassium? Do let me know. Fast, be quick. Do let me know who is going to snatch the electron. I want to see in the chat section. Then only you are going to understand. Otherwise, it's meaningless. Write it down speedily. Who is going to snatch the electron of potassium? Definitely this is being more electronegative. This is going to snatch. Being more electronegative, this is going to snatch electron of this. So it will form KCl. One story is clear. This was the first story. This is the first scientific story. I am telling you scientific story. Right? Now, second scientific story, see to it. Second, suppose there was one potassium and there was one iodine. Nobody else was there. no one else was there. So what will happen? It will form Ki. Later on, chlorine arrived over there. Later on, chlorine arrived over there. Now chlorine is asking what you did. You have snatched electron of potassium. I am being more electronegative. I am being more electronegative. I am being more electronegative. I will snatch this electron from you. So this chlorine will snatch electron from this and the reaction is possible. So it will form KCl plus I2. Are you getting my point? This is the second story. Just do let me know, are you able to understand or not? Being chlorine being more electronegative will remove this I negative and it will form I2 zero oxidation state. Two stories. Are these two stories clear to all of you? Are these two stories clear to all of you? Then only I am going to tell you the third story. If all these two stories are clear to all of you, then only I am going to tell you the third story. Now see, story number 3. Now suppose if there is one potassium, chlorine came over there, it has snatched the electron, it has formed KCl. Now 4 oxygens arrived over there. Now who is having electron? Electron is like money. Electron is like money. Electron is like money. And atoms are like human beings. I have told you a number of times, atoms like human beings. Human beings. Now this chlorine is having 7 of its electron plus 1 of potassium, 8 electrons it is having. Now these 4 oxygens, they will snatch electron and it will form KClO3, KClO4. Now chlorine is in plus 7 oxidation state, right? Chlorine is in plus 7 oxidation state. Now suppose if chlorine, if in front of chlorine this iodine is arrived over there, in front of this chlorine, iodine approach this chlorine, then who is being more electronegative? Who is being more electronegative? Definitely this chlorine is more electronegative. It can't snatch electron from oxygen because oxygen's electronegativity is 3.5, chlorine's electronegativity is 3.2 or you can say 3.00 and iodine is very less electronegative. Now this chlorine will say, hey iodine, you are having 7 electrons in the outermost orbit, I will snatch electron from you. I will snatch electron from you and it will form KiO3, KiO4, it will form KiO4 and this will be like K and I close Cl2 will be outside. Are you getting my point? So what is the basic difference? Basic difference in between KClE3 and KClO4 is that here chlorine is in minus oxidation state and here it is plus 7 oxidation state. It has taken electron, it has gained electron, electron rich, and here it is electron deficient. It is electron deficient. So can you get it? Is it possible? Now see, let me show you the question. The question which I have given to you. See to it everyone. See to it. Here chlorine is having minus and iodine is less electronegative, not possible. Here chlorine is in plus how much? Plus 5 oxidation state and this is more electronegative. So it is going to form KiO3 and plus Cl2. This is feasible. Here iodine negative oxidation state, this is more electronegative. So what it is going to do, it will form KCl plus I2, it will displace. Now here iodine is having plus 5 oxidation state, this is more electronegative, so iodine can't snatch electron from it. Now is it clear? Do let me know in the chat section if it is clear to each and everyone. Then I am going to move towards one more interesting thing about halogen. I am going to tell you that the most important thing about halogen, but first do let me know, is this concept clear to all of you? Hey kids, Do let me know, is this concept clear, very much clear to all of you? I think it's clear. If it is clear, do let me know in the chat section. Now, see everyone, there was one C. Let me show this C, and this C was having fish. The C was having fish. This C was having fish in it. Fish. Let me draw the fish. Fish. Now, there was one Titanic, and in this Titanic, who was moving? In this Titanic, fluorine, chlorine, bromine and I2 was moving, and all these four, they jumped inside the water. All these four, they jumped inside the water. All these four have gone inside the water. Then this fish said, thanks to fluorine only, thanks to fluorine only, F2 only. Now, you are supposed to find out why fish said thanks to fluorine only, because F stands for fish, F stands for fluorine. This is the reason, or some other reason is there. Fluorine, chlorine, bromine, they all jumped, and fish said thanks to fluorine only. Question arises, why fish is saying thanks to fluorine only? Why fish is saying thanks to fluorine only? Why not to others? No thanks to chlorine, no thanks to bromine, no thanks to iodine. What's the reason? What's the reason? What's the reason behind it? Because, oh great. Claps for Ion Furkana. You are exactly correct. Exactly, your answer is correct, Ion Furkana ji, because fluorine is the only one who is giving oxygen to this fish. See everyone, the reason I am going to deal with fluorine aqueous means fluorine reacts with water. Fluorine reacts with water. 2 moles of fluorine plus 2 moles of water, it will give you 4 times H plus 4 times fluorine negative plus oxygen O2. Only here oxygen is produced, only in this reaction. If I react chlorine Cl2 plus water, they are not going to release oxygen. It is going to form HCl and HOCl. Reaction will take place, but no oxygen. If I react with bromine, same reaction, H2O, HBr, HOBr, no oxygen. But if I react iodine, even what to say, this reaction is not possible at all. This is given in NCERT, not possible. Yes, NCERT says if I reverse the reaction, means 4 times H plus 4 times I negative plus O2, then I will get I2. This is possible, but this is not possible. Only this is providing oxygen. That's why fish said thanks to fluorine. Is it clear? Everyone got the answer? Hey, great, good. If it is clear, Do let me know. Now I am reaching towards zero group. I am going towards zero group. How was the story? Do let me know how was the story. Kids, you are not appreciating my hard work. How was the story? This story, scientific story I have told you. Fantastic, awesome scientific story I have told you about the fish. And you don't know how to appreciate it. Kids, now see everyone, see to it zero group. Everyone, let's move towards zero group. Then we are going to deal with the questions. Zero group, noble gas. Zero group, zero group. That is helium, neon, argon, krypton, xenon, radon. Now, there was one scientist, Bartlett. He got one red compound. He searched for red compound. That compound is O2 PT F6. This was the first compound. He traced it, he found it. Then what he realized, Bartlett realized that the ionization energy of molecular oxygen was approximately same as xenon. That is approximately 1280 kilojoule per mole, approximately. So then, with the help of this information, he prepared another compound that is known as XePtF6, and then he came to know that xenon can react with fluorine. Although otherwise they were known as non-reactive gases, noble gases. Noble gases means they are not going to form bond with anyone. But Bartlett, now see how to prepare. See everyone see to it. If we react xenon, I call it xeno. I call xenon as xeno. If we react xenon with fluorine and fluorine, see what it is going to give. Fluorine at 673 Kelvin, you will get XeF2. At fluorine at 883 Kelvin or 873 Kelvin, you are going to get XeF4. At low temperature, there is 7 bar pressure also. Fluorine in excess and temperature is 573 Kelvin, but pressure is 60 to 70 bar. High pressure, you are going to get XeF6. So these are the preparations. Now kids, if this xenon is going to react with water, this is the only thing which can be asked from this chapter, from zero group. This is the only thing. See everyone, see to it. If we are going to react it with water, it will form HF plus O2 plus xenon. But here in XeF4 plus water, it is going to form explosive. One explosive, XeO3, explosive pyramidal structure. plus same thing HF plus O2 plus xenon. Now this is very important. When it is going to react with water, it will show partial hydrolysis and complete hydrolysis, partial plus complete hydrolysis. The very important. Let me tell you how to do it. This is the most important question of the exam, partial hydrolysis and complete hydrolysis. Let me tell you, XeF6, see XeF6. Let me draw it like this: fluorine, 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 fluorine. I am not drawing it the correct structure or correct shape. I am going to explain the reaction. See, H2O. It is going to react with H2O. See how I am writing H2O. Now, what is going to happen? What should I write? See, this HF, and this oxygen will be taken by xenon. What are you going to get? You are going to get Xe fluorine, 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 and one oxygen over here. You can write it like this: XeOF4 plus twice of HF. Am I right? Am I right? Now, if it is reacting with one more mole of water, what I can write? I am going to write it like this: HF has gone. What I am going to write? I can see XeO2 F2 plus 4 moles of HF. Now, if it is going to react with all fluorines are getting replaced, what I will get? I will get complete hydrolysis, XeO3 plus 6 moles of HF. So, all they are formed, all are the products, all products have been detected. So, this is all about P block, whatever the questions they can ask. So, let me show you the questions. Then I am going to deal with the most important thing. See, first of all, let me show you the questions, what questions they can ask. Identify the correct formula of oleum. Yes, NEET 2019. NEET 2019. What's the answer? Kids, what's the answer? Correct. Speedily give out the answer. Speedily, I want to see the speed. Identify the correct formula for oleum. Even Wassim sir has told you the structure of it. 1, first H2. Yeah, correct answer. Yeah, right. Absolutely correct. Another question. Okay, group 17. Let me move a little bit back so that maximum questions you can do, kids. Maximum questions you can do. This question you can do later on, homework. This question is also homework. Questions you can do by yourself, okay, I think. Number of questions we have given. Silicates. Let me give you the trick for silicates. This is the most important thing. Let me give you the tricks for silicates. See, then we can do this question. Let me give you the trick for silicates. See everyone, silicates. Awesome trick I am going to give you, but let me explain it first. What are silicates? Suppose if I am having SiO negative, O negative, O negative, O negative. This is known as orthosilicate. This is known as orthosilicate. Do remember, this is known as orthosilicate. Even I can write it down like this. Suppose this yellow one is silicon and these white portions, this white one is O negative, oxygen, right? So how can I draw it? This is silicon and one oxygen at this place, one oxygen at this place, one oxygen at this place and one oxygen at this place. Tetrahedral, you can see it like this. Tetrahedrally it is like this, 1 bond, 2 bond, 3 bond, like this, and this is tetrahedral structure of orthosilicate. Can you see? Everyone, can you see to it? This was 1 bond. Now kids, this is the tetrahedral structure. Can you see? This and this, they mean same. Both mean same. Can you see? Then only I can explain it. Then only I can make it possible. You can understand it. Once let me know this structure is clear. Both mean same. This and this, both are same. Both are same structures. Now let me tell you a little bit logic about it. Here all the oxygens are free. 0 oxygen has been shared. 0 oxygen is shared. Means all the oxygens are free. This is having negative charge. This is having negative charge. This is having negative charge. All 4 are having negative charge. That means I can say SiO4, 4 negative. This is your orthosilicate. So if examiner is asking in orthosilicate, how many oxygens are shared? The answer will be 0 oxygen. 0 oxygen has been shared. Are you getting my point? Are you getting, everyone getting my point? Very good. Now see, if somebody is asking in pyrosilicate, let me draw the pyrosilicate, then I will give you the trick. How pyrosilicate will look like: SiO negative, O negative, O negative, SiO negative, O negative, O negative, and this oxygen is shared. So this oxygen is common to both of them. This oxygen is not having charge, uncharged. This oxygen is without charge, without negative charge, without negative charge. Why it is without negative charge? Because one oxygen is shared. One oxygen has been shared. Right? One oxygen has been shared. That's why it is not having any charge. So what I can write? Si2O7, and how many negative? 1, 2, 3, 4, 5, 6. 6 negative. So this is pyrosilicate. So examiner is asking, if examiner is asking how many oxygens has been shared by pyrosilicate, how many oxygens are shared? Yes. So the answer is 1 oxygen has been shared. So are you ready for the trick? Everyone ready for the trick? Everyone ready for the trick? See, I am going to give you OP trick for it. I am going to give you I am going to give you OP trick for it. See OP trick. Number of oxygen shared. Number of oxygens shared. C. And type of silicate. OPCS. OP computer science. What is the trick? OP computer science. OP computer science. Say everyone, OP computer science. OP computer science. Now, O stands for orthosilicate. Orthosilicate. P stands for pyrosilicate. C stands for chain silicate and cyclic silicate. S 2D sheet silicate and 3D sheet silicates. Now number of oxygen shades are 0, 1, 2, 3, 4. OPCS, OP computer science. For orthosilicate, how many oxygen shade? 0. For this, 1. For this, whether chain or cyclic, 2. For this, 3, and this 4. So this is the trick. You like the trick? Super awesome trick I have given you with Chalog. Now to show me the energy level, that good trick I have given you. OPCS, orthopyro, chain or cyclic, sheet 2D, sheet 3D, 0, 1, 2, 3, 4. This is going to be the answer. Directly without drawing the structure, you can do it. This question has been asked number of times. Number of times this question has been asked in examination. Number of times this oxygen has been asked. Do let me know in the chat section you got it something or not, kids. Now I have told you each and everything about P block. Now I am going to give you the awesome trick, but before that let us solve this question. The basic structural unit of silicate is NEET 2013. The basic unit of silicates is, yes, ABCD. Everyone, ABCD. I want to see the answer. ABCD. I can't give the break because I cannot extend the class. So we have less time. No break can be given. Sorry, kids. What's the answer? I want to see the answer. Aris, increase the speed, everyone. Kids, Bachcha party, increase the speed. SiO4 2 negative. C is the correct answer, right? Oh, C nahi. SiO4 4 negative. C, this has gone. Your answer has gone wrong. Those who have given C to be the answer. Those who have given C to be the answer, examiner is going to give you 0 marks. 0 marks. Those who have given C, they have got 0 marks. 0 marks for C. This 0 marks. This 0 marks. So the correct answer is SiO4 4 negative, orthosilicate. Maximum up to 5:30 or 6. I can extend this class. Now let's move ahead. Here is the question. Answer the following question. Assertion reasoning, NEET 2022. Let me see who is going to give the correct answer. I've told you each and everything. Yeah, coordination chemistry I am going to tell you. The most important thing I am going to tell you, I am going to let you know about the coordination chemistry. Yeah, before 6 I am going to end this. Kids, fast. Fast, fast. Fast. So let's see this boiling point order, the boiling point. So let me check it out. Both 1 and 2 are incorrect. Oh, both 1 and 2 are incorrect. Why they are incorrect? You should know, because of intermolecular hydrogen bonding. Intermolecular hydrogen bonding, H2S can't have boiling point more than water. Now another question, the correct order of boiling point. This is really awesome question. Very, very important question. Very, very important question. Very, very important question. Kids, this is really super awesome question. Very, very important. So let me tell you the trick for it. Let me tell you the trick for it. Before, what was the question? Its answer must be intermolecular hydrogen bonding. Who is having intermolecular hydrogen bonding? Intermolecular hydrogen bonding. Water is having, H2O is having intermolecular hydrogen bonding, although its molecular mass is less. H2O's molecular mass is just 18 and H2S molecular mass is 34, but then also this is being gas and this is being liquid. So what is the reason for it? Reason is intermolecular hydrogen bonding. Clear to all of you? Clear to all of you now? Next question. Nitrogen, phosphorus, arsenic, antimony, bismuth. So hydrides are given over there. Do remember, with the increase in molecular mass, boiling point increases. Boiling point is directly proportional to molecular mass, but do remember it is simultaneously directly proportional to intermolecular hydrogen bonding also. Intermolecular hydrogen bonding also. Who is going to show intermolecular hydrogen bonding over here? This will show intermolecular hydrogen bonding. So due to intermolecular hydrogen bonding, its position is over here, in between these two, So what the answer you are going to get? You will get PH3, then ASH3, then in between these two there will be ammonia, then SbH3, then bismuth H3. So this is the boiling point order, BP order. So what's the answer? Ammonia is in between. Phosphorus arsenic, where is phosphorus arsenic? Phosphorus arsenic, what is the answer? What answer you are going to get, kids? I've told you each and everything. Now just do let me know in the chat section what answer you are going to get. Yes, kids, fast. This ammonia will come in between these two. This ammonia will occupy position due to intermolecular hydrogen bonding. It will come in between these two. That means ammonia must be in the middle. So ammonia is in the middle, ammonia is in the middle, ammonia is not in the middle. So they can't be the answer out of these two. Bismuth hydride is having maximum, then antimony is having, then phosphine arsenic. Second will be the correct answer. Second is going to be the correct answer. Second is going to be the correct answer. Yes, we got it. We got it. Clear to all of you? Is it clear to all of you, kids? Now What does heating copper with concentrated HNO3? This I have told you. Do let me know what's the answer. I have told you, I have explained it. I have explained it. Do let me know what's the answer. I want to see the answer, everyone. Do let me know what's the answer. Yes. Do let me know in the chat section. I have told you, whenever any metal nitrate is heated with concentrated HNO3, so metal nitrate is going to give you, suppose copper nitrate CuNO3 whole twice, it's heated, you will get CuO plus naughty gas, you will get naughty gas plus water, naughty gas, NO2 gas, NO2 is given over there, copper nitrate and NO2. I will go for the fourth option. Fourth one. Correct answer. Very good. We have got it. Fourth answer. That's really awesome. Really awesome. Fantastic question, rank deciding question. This question is being rank deciding. Just try to answer it. Rank deciding question. Rank deciding question, kids. Rank deciding question. Try to understand it, then answer it. Really awesome question, really fantastic question. If you are able to solve it, you can do anything, kids. This is the most important question. Although it has been asked in NEET Odisha 2019, but this question is really awesome. See, a compound X upon reaction with H2O produces a colorless gas by with rotten fish smell. You got it? Rotten fish smell. Rotten fish smell is indicating this is being phosphine gas. Kids, phosphine gas, I have told you, is absorbed in the solution of copper sulfate to give Cu3P2. I have told you this also. This also I have told you. Now, as one of the product, predict the compound X. The compound X on treatment with H2O produces. So, Capto. Do you remember Capto? Capto. Your Capto, sir. He has given you marks. Capto. I have given you the trick. That trick is working or not? Do let me know that trick is working or not. Yes, that trick is working. If that trick is working, show me the thumbs up. Kids, show me the energy level if the trick is working. That Capto trick I have given you. See, this reaction I taught you. Or not? Calcium phosphide, phosphine gas, phosphine plus copper sulfate. You got this one. Cu3P2. All these two reactions I have already taught you. See, these reactions already I have explained. I have already explained these reactions, kids. Here is the question. This question has been asked in NEET 2016. You can see NEET 2016. This question has been asked in NEET 2016. Which one of the following orders is correct for the bond dissociation enthalpy of halogens? I have given you trick. Which trick I have given you? Just do let me know, kids. I have given you trick for this. Bond dissociation energy. Which trick I have given you? Do let me know. First of all, do let me know. B. Everyone saying Capto bro, Florida to India. Absolutely correct. Capto bro, Florida to India. Two questions. You have got answers of two questions because of your Capto, sir. You have got two answers exactly correct from P block only because of your Capto, sir, isn't it? Your Capto, sir, wherever Capto, sir, if you are listening, please, these kids got 10 marks because of you. Capto bro, Florida to India. That's really awesome, really awesome. Fantastic, awesome question. NEET 2022. This question has been asked in NEET 2022. Try to understand. Assertion and reasoning. Assertion and reasoning based. Assertion and reasoning. Let's see how many of you are able to do it. How many of you are able to do it? Let me check it out. How many of you are able to give the answer? See, ICl is more reactive than I2, right? ICl bond is weaker than II. What will you say? Really very tough question. Very tough question. Very tough question. Let's see how many of you are going to get the correctly solved. How many of you are able to solve it? Let me check it out whether your answer is correct or wrong. Both A are and true and R is the correct explanation. See why it is more reactive. In I2, the electron distribution is symmetrical. Electron is symmetrically distributed. And here the electron is not symmetrically distributed because this is having delta positive and this is having delta negative. Poor friendship or weak friendship, not a good friendship, bad friendship, bad, better to say weak friendship. This is weak bond and this is being strong bond, right? That is being weak bond, this is being a strong bond. And ICl bond is weaker. Already I have told you ICl bond is weaker than II because here charge separation is there and electron is shifted more towards chlorine side because this is minus I and that is acting as plus I. Plus I means electron withdrawing, it is electron donating group and that is being acting as electron withdrawing group. So friendship is not good. Okay. Wow, oh, you got the answer. You have seen the answer. Already answer is displayed. So, see to it. Which of the following statement about halogen is false? Halogen I have told you. Halogens I have told you. I want to see whether you are able to do it or not. All form of monobasic oxy acid except HOF. All form monobasic oxy acid. Monobasic oxy acid means like this, XOH double bond O. This is monobasic acid. Monobasic acid. So I can say HXO2. HXO2. They are talking about HXO2 and they are talking about which of the following statement about halogens is false. Focus over here. False. All are all but fluorine show positive oxidation state, right? Fluorine will show positive oxidation state or negative. Yeah, fluorine is definitely negative. Chlorine has the highest electron gain enthalpy. This is the absolutely true. So what answer you are going to give, kids? Let me see what answer you are going to give. See, let me check it out. Chlorine has highest electron gain enthalpy. Which of the following statement about halogen is false? This is not false. So there must be true. This must be true, kids. This is the true statement. Chlorine has highest electron gain enthalpy. They are not going to form, all form monobasic acid except HOF. This is false. All are, this is false. So there can be true, then only it is going to be true. Are you getting my point? Are you getting my point? So there is a little bit correction is required. Correction is required over here. Clear to all of you? Is it clear? Is it clear? Fluorine -1. Here fluorine is all form monobasic acid except all form monobasic acid except HOF. This is also, this is there but not stable at room temperature. They can't say like this कि HOF does not exist. HOF exists at a lower temperature. Let me check it out. Let me check it out. See to it. If I write it like this, okay, let me check it out. Which of the following statements about halogens is false? Chlorine has highest electron gain enthalpy. This is the true statement. How it can be false? This is just the true statement, isn't it? Chlorine has, oh, negative is missing over here. Negative is missing over here. See, negative must be there. So if negative is there, this can be true. Without negative it is false. Without negative it is false. Because highest electron gain enthalpy means nothing. This is meaningless. Highest electron gain enthalpy meaningless. Negative must be given over there. Are you getting my kids? Is this point clear to all of you? Are you able to understand? If negative word is not there, that doesn't mean anything. Are you getting my point? This is meaningless. Without negative it is meaningless. Kids, is it clear to all of you? In this statement, negative electron gain enthalpy must be given, then it is true. Negative electron gain enthalpy, if it is given, then it can be true. Then it can be true. So I hope everyone got it, and this is stable only, stable at low temperature, stable only at low temperature. So clear to each and everyone? So take care of it. This question is really very awesome. Take care of it. Okay, this question is really very awesome. Now all but fluorine show positive all but fluorine shows positive oxidation state. This is wrong. All fluorine is always going stable. If we talk about, always shows stable negative oxidation state. So leave this. This options are random. Options are not up to the marks. Options are not up to the mark. So leave it. Leave it. Is it clear to all of you? Now everyone, see K104, potassium permanganate. I am going to give you the memory chart of potassium permanganate. Okay, Everyone, are you ready? First, I will let you know about KMNO4, then I will tell you the colors of coordination chemistry. How is the Josh? How is the Josh? KMNO4, I am going to tell you about KMNO4. Memory chart of KMNO4 I am going to give you. See everyone. This is your KMNO4. Mind map or memory map of KMNO4 I am going to deal with. Everyone see to it and try to put in your brain. Mind map of KMNO4. Mind map of KMNO4. See everyone, this is KMNO4. How much is the oxidation state of KMNO4 over here? +7. The color of KMNO4, everyone try to give me the answer. What is the color of KMNO4? P, R. P stands for pink. P stands for purple. R stands for red. Any of the color it can have. Now the oxidation state is +7. +7 means no unpaired electron is present. No unpaired electron is present. See to it everyone. This is indicating no unpaired electron. When no unpaired electron, then no DD transition. No DD transition. Then who is responsible for the color? What factor is responsible for the color? If no DD transition, then what factor? So the answer is charge transfer spectra. Charge transfer spectra. This is the answer. Charge transfer spectra is responsible for its color. Now see everyone see to it. If I say it is in acidic medium, if I say it is in neutral medium, if I say it is in faintly alkaline medium, faintly alkaline, or it can be simply given as alkaline, alkaline can be mentioned. And if I say strongly alkaline medium, strongly alkaline medium. So do remember one code for it. Let me give you one code for it. Anna. A-N-A. Anna. Acidic, neutral, alkaline, strongly alkaline. Right? So better to say Anna, Ansa. Ansa, Ansa. Acidic, neutral, strongly alkaline. Ansa. Acidic, neutral, strongly alkaline. Now see to it. Over here you are getting Mn2 plus, that is being colorless. MnO2 black colored. K2MnO4, K2MnO4 green colored. K2MnO4, K2MnO4. What are the colors? I have given you one short also for this. This is colorless. Colorless. This is black colored. This is green colored. Potassium manganate. This is known as potassium manganate. This is known as potassium manganate. Potassium manganate. This is black colored powder. Black powder. Black powder. MnO2. What is the oxidation state? See here 2 plus, here 4 plus, here 6 plus. 2 1 ja 2, 2 2 ja 4, 2 3 ja 6. So this I am going to give you now in a small font. Small font. See how many people are able to understand it. See to it. Everyone see to it. Now I am going to give you the in small font. This is being KMNO4. KMNO4. And the medium I am going to give you. See everyone. See to it. Acidic medium, neutral medium, alkaline medium. Everyone focus over here. acidic medium, neutral medium, or faintly alkaline medium, strongly alkaline medium, just do let me know what I have told you. What I have told you, kids. Over here, what you are going to get, you will get Mn2 plus colorless, MnO2 black colored, K2 MnO4 green colored. Now see to it, I am going to extend it. See everyone, from here the oxidation state +7 to +2. What is the N factor? N factor is 5. +7 to +4. What is the N factor? N factor is 3. +7 to +6. What is the N factor? N factor is +1. Now see to it everyone, if I treat, everyone see to it, ferrous in acidic medium with KMnO4, what you will get? Do let me know. Ferrous acidic medium with KMnO4 acidic medium, what you are going to get? It will convert into ferric. Ferrous will convert into ferric. That means ferrous is undergoing oxidation and it is getting converted to ferric. Are you able to understand? And this KMnO4 will change into Mn2 plus. I think this point is clear to each and everyone. If I say sulfide will convert into sulfur. Do remember, sulfide will convert into sulfur. If I say I negative, so I negative definitely is going to convert into I2. No need to cram it, just it is undergoing oxidation and KMnO4 is undergoing reduction because this KMnO4 is SOA. SOA means strong oxidizing agent, strong power to undergo reduction. So ferrous, if I write stannous will convert into stannic, SN4 plus. But the most important part I am going to tell you, that is very, very important. Everyone try to understand it. If I treat I negative with KMnO4 in faintly alkaline medium, KMnO4 in faintly alkaline medium or neutral medium or faintly alkaline medium, what do you get? This is the most important question, kids. This is the very, very important question, very, very important. You will get IO3 negative. Do remember iodate. Here you got I negative converted to I2. That was acidic medium, but here it is what? Here it is, kids. What is over here? Just do let me know. Here I am saying it is in faintly alkaline medium and you are going to get different answer, and this is the point to be noted, my lord. This is really very, very important point. You should remember it. You should know it. So this is really very, very important thing. This is really very, very important thing. My dear kids, are you able to understand it? Now I am going to the most important part. I am going to deal with the most important part. See everyone see to it. I am going to tell you about color of coordination chemistry. Color of coordination chemistry. See to it everyone. The most important thing, color of coordination chemistry. How many of you feel difficulty over here? Color of complex compounds without rectification, without cramming, just with the help of brain. How many of you want to gain that power? No cramming, only with the logics, only with the logics. Any color you can find out, any color you can find out, any color, any color. Yes, if you want it, you have to follow me. If you want, this is going to be the most important part. If you want it, do let me know in the chat section. If you want it, those who can understand it, for this a little bit of brain is required. Little bit of brain will be required. Use of brain will be required. For this, use of brain will be required. Brain plus memory will be required. If you are ready, then do let me know. I can start, I can let you know. If you are ready, show me in the chat section. If you are ready, if you can do this much, definitely I will let you know how to get the color of any this coordinate compound without remembering it. No need to cram it. No need of rectification. What I can see in the chat section. Yes. So very good. Everyone do write yes. If you want, show me the thumbs up. Okay. Everyone agreed, everyone. Okay, see to it. See to it. First point you should know. First point, you have to know the spectrochemical series order. Spectrochemical series order. Spectrochemical series order. This is the first point. Spectrochemical series order. This is the first point which you are supposed to know. You have to keep it in your brain. I am writing it down. Just try to keep it in your brain. Okay, so this is strong field ligand. These are strong field ligand. Can you keep it in your brain? These are being strong field ligands. Strong field ligands will do more splitting. Strong field ligands will do more splitting. First point, strong field ligands will do more splitting, means more energetic light will be absorbed. More energetic light will be absorbed. First point, strong field ligands will do more splitting, more energetic light will be absorbed. This is the first point. Second point. Second point is higher oxidation state on metal. Higher oxidation state on metal is responsible for more splitting. More splitting. That means if I say cobalt 3 plus and if I say nickel 2 plus, who will do more splitting? This will do more splitting, more energetic light will be absorbed. More energetic light will be absorbed. Less energetic light will be absorbed. Are you getting my point? These 2 points you have to keep it in your brain. One more point I am going to tell you. Everyone, just show me the thumbs up at least. These 2 points are clear to all of you. One, stronger the ligand, strong field ligands will do more splitting. Strong field ligands will do more splitting, and higher the charge on central metal atom, more splitting will be done and more energetic light will be absorbed. Now the third point is the color wheel. Third point is the color wheel, kids. Third point is the color wheel. See to it. Let me divide in 2 parts. Let me divide it 2 parts. Let me divide in 2 parts. I have divided in 2 parts. This is high energy area. Left hand side is high energy area. This is high energy area. Left hand side is high energy area, kids. And right side is less energy area. Okay, less energy area. Now let me tell you why I have divided it like this. For what reason I have divided it like this? I have divided into these many parts. I have divided it into these many parts. Now see, this color is VIP color. What does it mean? VIP. Vibgyor. I am going to write down Vibgyor. V for violet or indigo. I for indigo. P for purple. Whatever the color is given. So this is maximum energetic light, means least wavelength. So I can say 360 nanometer. And here is red. Red is maximum wavelength, least energetic, 720 nanometer. Your paper of bio is 360. Bio paper is of 360 and maximum 720. So you can learn this length, nanometer. This much is the wavelength. 720 is full marks. 720 nanometer. So after violet indigo, what I am going to get? Which color? I will get blue color. This is the area of blue color. Then after blue, I will write green color. Here is the area of green. This is the color wheel. You need you need to undergo with these colors, and you have to put it in your brain. Color wheel. Green. After green, yellow color. After yellow, orange color, and then red. So can you see the complementary color? First of all, we have to understand the complementary color. What is the complementary color of blue? Blue's complementary color is orange. Orange's complementary color is blue. Green's complementary color is red, and red's complementary color is green. Or most probably it can also be given as beggar. What is this beggar? Blue green will give you red. Blue green all together they are going to give you color red color. So you have to go through these complementary colors. First of all, this is the third parameter. First parameter was ligand field theory. Strong field ligands causes more splitting, more energetic light will be absorbed. Second was more is the charge on central metal atom, more will be the splitting and more energetic light will be absorbed. And these complementary colors, just do let me know if these 3 points are clear to all of you. I will tell you all the colors of coordinate entity, whatever is given in NCERT. Show me the thumbs up if you are ready. If all these three things are clear in your brain, do let me know, then I can start. Everyone, do let me know all these three things. If they are clear in your brain, then I will tell you each and every compound's color. At least I can see the energy level, how much energy is left. Just I am going to tell you this thing for 20 minutes only. I have 20 to 25 minutes only. Okay, see to it. Let's see. See everyone. If I talk about compound NCERT, there is table given in NCERT, table given in NCERT, and let me talk about that tables, compound and colors. Table is given in NCERT. See, in that table, it's given like COCN whole 6 3 negative, first compound. CO ammonia whole 6 3 positive. CO ammonia whole 5 H2O. CO ammonia whole 5 Cl. If you want to see, you can see even your NCERT simultaneously. If you want to see, you can check your NCERT and you can check the colors also. You can even check the colors also. Now see, out of these 4, all they are having 3 positive oxidation state, all they are having cobalt in +3 oxidation state. Here the cobalt is in +3 oxidation state, cobalt is in +3 oxidation state, cobalt is in +3 oxidation state, cobalt is in +3 oxidation state. So in this 4, out of these 4, which is having strongest field ligand? Out of these 4, which one is having strongest field ligand? So this is the strongest field ligand. So definitely it is going to show maximum splitting. So maximum energetic light, it is going to absorb maximum energetic light. So which light is maximum energetic light? I would like to say visible, before visible it's ultraviolet to visible. It is that much strong. So it is going to absorb ultraviolet to visible. That means wavelength 300 to 360 nanometer light. It is going to absorb. So if it is absorbing this light, see, it is absorbing this light. What is the complementary color of this? It is going to absorb violet light, ultraviolet, visible light. It will look yellow, and it is absorbing some here, somewhat over here. It will look like yellow or light yellow, because this is visible range and before this there is ultraviolet visible range. This is going to look like, this will look like, definitely this is going to absorb light of maximum energy. We can say ultraviolet to visible, and in visible range I can say VIBGYOR, violet light it is going to absorb. So this light is absorbed by this entity. So the color of this compound, color will be light yellow. See your NCERT, color given must be light yellow only. COCN6 3 negatives color must be given light yellow. Check it out. If you are having coordination chemistry, kids, check it out. Light yellow or yellow must be given. Do let me know. Light yellow or yellow must be given. Kids, I am doing a really very hard work. I am a very simple teacher, but really hard working. You just do let me know. Keep NCERT with yourself. Please everyone, keep your NCERT with yourself and do let me know, am I right or not? Light yellow, pale yellow means same. It is given over there. Now, ammonia is weaker ligand than that. It is strong field ligand but weaker than that. So, which color it is going to absorb? See, little bit less than this, little bit less than this. So, ammonia is going to absorb this color. Ammonia is going to absorb this color. So, it is absorbing blue color. So, it will look like orange. So, this molecule is going to absorb, it's going to absorb blue color and it will look like orange colored, yellow orange or orange, yellowish orange or orange, either to yellowish orange or orange color. This is the absorbed color and this is the color of the complex compound. One is absorbed color. This color is absorbed by the entity and this is the actual color of that entity. This is the actual color of that entity. Do let me know in the chat section, am I right or wrong? I'm trying to make it scientific. I'm just trying to make it scientific. Those who are able to understand, please do let me know how many of you are able to understand. How many of you are able to understand? Kids, how many of you are able to understand? Do let me know in the chat section. How many of you are able to understand? It can be given yellow, orange or yellow. What I am saying, either yellow, yellowish orange or orange. Either of the color can be given. Now see, this ammonia is only 5, 1 water is there. Less, see, it is going to absorb color somewhere like you can say here. Green color, then red color. If it is absorbing blue green is also red, green is also red, blue green is red, this is red, both are red. So, definitely the color of this compound is going to be red. Color of this compound is going to be red because it is absorbing blue green. If it is absorbing blue green, then also red. If it is absorbing only green, then also it will look like red. So, this compound must be going to be red. Just do let me know, this CO ammonia whole 5 water is given red or not? It is given red or not? Do let me know it is given red or not. Now, chlorine is even weaker ligand. Now, it is going to absorb color somewhere like here yellow. So, it will look like violet, indigo, purple, violet, indigo or purple. So, it is going to absorb yellow color. This is going to absorb yellow color. So, definitely it will look like purple, violet like that. Violet or purple must be given. Violet or purple must be given. See, now you must be thinking how to do it. You are the simple kids. First, do let me know, my dear kids, you must be thinking that how to answer it. Now, let me tell you first of all, no need to go for that much of knowledge. See how to answer the question. See everyone see to it how to answer the questions. I am going to give you those questions only which have been asked. See, if they have given you the question like this, what is the color of COCN whole 6 3 negative? See to it. Options will help you a lot. This was the question already asked in AIMS. First is violet, second is blue, third is blue green, fourth is yellow. Now, could you please let me know how to do this question? See, This is cobalt 3 plus and this is cyanide strong field ligand. Maximum energetic light they are going to absorb. When maximum energetic light they are going to absorb, definitely the color will on the right hand side only. See, color will be from the right hand side only. So, which colors are not possible? These colors are not possible because it has to absorb color in this area only, and if it is going to absorb these colors, the color will look like this only, either yellow, orange or red. See to it. See to it. If this is absorbing color on the left hand side only, if this compound is absorbing color from the left hand side only, this area only, it is going to absorb color from this area only. See to it everyone. If this is going to absorb color from this area only, either it is to going absorb color violet, indigo, blue, yellow, either of these color it is going to absorb. That means the color of the compound will be either red or orange or yellow. Out of these three could be the answer. That means this can't be the answer. This can't be the answer. This can't be the answer. This not over here yellow. It was green. It was green. 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 Green, blue, green can't be the answer. Can't be the answer. Only yellow is going to be the answer. How many of you are able to understand? Do let me know. Kids, do let me know. Are you able to understand it or not? Is there anyone who is able to understand it? Now suppose if they are asking question, if one question, let me ask the question. Which color light will be absorbed by CuSO4 dot 5 times H2O. Options are option A blue, option B violet, option C orange, option D red. What's the answer? This question has been asked in IIT. In IIT this question already has been asked. Already asked in IIT. Already this question has been asked in IIT. Do let me know what's the answer. Let me check it out whether you are able to give the answer or not. Kids, do let me know what's the answer. Yes, do let me know everyone. Most of them they are writing A. Definitely your answer, examiner will give you big 0. If you are writing A to be the answer, examiner will give you big 0. Absolutely incorrect. See the language of the question. What he has asked, which color light will be absorbed. He is not asking what is the color of CSO4. If he is asking color of CSO4, color of CSO4 is blue. But what is the complementary color of blue? That is being orange. So he is asking what colored light is absorbed. Everyone, are you getting my point? What he is asking, what colored light is absorbed? Everyone, if it is clear to all of you, just show me the thumbs up, kids. If you are able to understand. See, now see everyone. See, few more questions, let me tell you. See, in your NCERT it has been given. In your NCERT these 4 compounds, more 4 compounds are given. Nickel, H2O, whole 6, 2 plus. First compound, second compound, see to it. nickel H2O whole 4 En. This is given on the right hand side. Everyone just take out your NCERT, open the page, on the right hand side it is given, just see to it. Third one, nickel H2O whole twice En2, 2 plus. Fourth compound is given over there, nickel En whole thrice. En is bidentate ligand. Now can you see, nickel in all the 4 cases, nickel is 2 plus. 2 plus means more splitting or less splitting. Nickel 2 plus means less splitting, more splitting. Definitely less splitting. Less splitting. Less splitting means less energetic light. Less energetic light will be absorbed. And if once the less energetic light is absorbed, what will be the color? More energetic color will be shown by it. More energetic color will be shown by it, or less energetic color? More energetic color will be shown by it. More energetic color will be shown. Am I right? Are you able to understand this much? Now these ligands are weak field ligands. Water is weak field ligand, En is strong field ligand. Now see here 2 plus and water is being weak field ligand. That means least energetic light. Who is the least energetic light? Do let me know. Least energetic light. Who is the least energetic light? Red color. It is going to absorb red color. Will absorb red color. Will absorb red color light. So if this is absorbing red color light, what is the complementary color of it? Green. Green is the complementary color, so it will be green colored. This compound is green colored. Just see it in your NCERT. This compound will be green colored. Check it out your NCERT. It's given green colored or not. The compound's color must be given green. On the right hand side, test tubes are shown over there. Now I am going to end the class, no break. Green color is given over there. Green color is given over there. Everyone see to it, NCERT. Now see everyone. Here is one En. One En is strong field ligand, little bit strong field ligand. So it will absorb. Let me draw the color wheel over here. Colors are violet, indigo, purple, blue, green, yellow, orange, red. So it has absorbed red light, so it was looking green. Now it is a stronger field ligand, but only at one place. Rest of other 4 are weak field ligands. So it is going to absorb a little bit more energetic light. Let us suppose it is going to absorb somewhere here, like either in between red or orange, or orange. If it is absorbing orange color, it will look like blue. It is absorbing in between this, it will look like light blue. So its color must be either light blue, because it is absorbing orange light. Orange light absorbed. Orange is absorbed. So it will look like either to blue or light blue. Either light blue or it will look like blue. What is given in your NCERT? Its color, this compound's color must be given as either blue or light blue. Blue or light blue. It's given over there. Just do let me know. Blue color is given over there. Everyone, are you able to understand? No need to cram the color. This is the trick which I am going to give you. This is fundamental based. Everyone is worried about the color of complex compound, and I am going to give you these golden words, diamond trick I am going to give you. Now see, here we have got 2En, 2En, 2, these are 2. Same nickel, nickel 2 plus is only there. So definitely in this area it is going to absorb light on the right hand side area only. So let us suppose either to it is going to absorb orange or in between orange and yellow. So it will look like violet, blue violet, in between blue violet. So it will absorb the light, it is going to absorb light in between orange and yellow, orange yellow light it is going to absorb. So its complementary color will be in between blue violet, in between blue violet, am I right? Blue violet. So either violet must be given or blue must be given. Now we have got 3En. So 3En means it is going to absorb light somewhere like here. So it is blue. So it is going to absorb, yellow light is absorbed. So it will look like violet or purple, violet or purple, like this. All these colors which I have given you, are you able to understand? Kids, everyone, are you able to understand this trick? Are you able to understand all the colors I have shown to you? Now say, if examiner is giving you this color, see, if examiner has given you compound like this, CuH2O whole 4 2 plus, you can see only 4 is the coordination number. Coordination number is 4. Now least splitting, tetrahedral splitting is less. Tetrahedral splitting is just 4 by 9 of octahedral. So least splitting means बच्चा लोग least energetic light. Who is the least energetic light? Who is the least energetic light? Who is the least energetic? Red is the least energetic. So it will absorb red light. If it is absorbing red light, what will be the compound's color? Either water I can write, or I can write in place of this ammonia, whatever I can write. Let us suppose if I write water, or I can write ammonia. So it is absorbing red light. So what is the color of the compound? Its complementary color is blue green. Blue green, am I right? So either it will look blue or it will look green, like that. So it must be given an NCERT. I think everyone got it. Green is given. So how many of you are able to understand? Because now at 6 Ambika ma'am's class is there. So I have to leave, kids. I have to go. I have told you each and everything. I have given idea about each and everything. So my class is over, kids. These things definitely, if you are able to understand these many things, you can do all the questions. All the questions of Inorganic, they will come from here only. From this marathon, whatever the mind map I have given to you kids, all the questions definitely they are going to come from this marathon only. I've told you each and everything kids. Chromate I have given one video with bacha. I have given one video on chromate and dichromate. Mind map of chromate and dichromate is there on your Unacademy NEET English channel. That is of 15 minutes video. In 15 minutes video, I have already given one memory chart kids. So, we are waiting for 1000 questions. All the teachers are busy in preparation of those questions only kids. Tomorrow is really the mega day. Those 1000 questions means your paper. Definitely I am saying that we have given that much of time. So that is going to be the most predicted question paper like that. I'm damn sure kids, I'm damn sure questions will come from there only. We have given that much of time to those 1000 questions. They are not random questions. We have given all experience and really too much time. Everyone is busy in those questions. Kids, really tomorrow you are going to get most expected. I would like to say the paper of NEET 2023 only. You are going to get paper of NEET 2023 if you are able to solve those questions. That's not only the paper kids. That come with the preparation. How many questions you are able to do. If you are able to solve at least 70% questions of those 1000 questions, if you are able to solve 700 questions, that means your preparation is up to mark, because options will help you a lot in your examination time. But that tomorrow's session is not the session, it's the festival before NEET 2023, or you can say that is the paper of NEET 2023, paper before the paper. Paper before the paper, because paper will increase your heartbeat, and this NEET 2023 paper before the paper of 1000 questions, that is going to give you the some what to say oxygen to your preparation. So kids, do your best, prepare, but simultaneously I would like to say one thing: have your proper fooding and proper sleep, sound sleep of at least 7 hours. Tomorrow we are going to give you 1000 questions. That doesn't mean you are not going to sleep the whole night. Take your sound sleep. That is the most important thing. Second thing, have proper food. Then come with your full memory, full josh, and try it out and check it out how many questions you are able to do, because these questions are neither of low level nor of high energy level. These are exactly those questions which are going to be asked on NEET 2023. From the last 23 years, I am giving the concept, the questions, and we teachers, all that team you know very well. This team is, whatever the questions this team is providing, paper we have seen is coming out from these questions only. This is our experience, this is our hard work. Neither I will say alone experience or alone the hard work. This is teamwork. This is teamwork, and team means a lot. So, all the best. May I leave? Your HSP along with the team. Bye. Bye kids. Bye. Bye kids. And at the last I would like to say, if you think NEET 2023 2-3 is going to be tough. Radu Kastama, Elle, it's going to be Romba Sulbham. So have faith on yourself and try to appreciate yourself, because in this world there is no one else who is going to appreciate your hard work. Always do hard work and appreciate yourself. Never forget to appreciate yourself, because there is no one who is going to appreciate you. If anyone is appreciating, that is extra thing. Just try to appreciate yourself. I will pray to Almighty God. May Almighty God bless these people with the best rank, with the government seat. I pray to Almighty God from the internal core of my heart, from my team. So, my team, yesterday we went to the temple. You know, yesterday was Tuesday. We have gone to Hanumanji temple. We have prayed to God that bless these kids with the best rank. Really, after completing our session, that was at 11:30, we have completed the session. After Ambika ma'am's class, we have gone to the temple and prayed for you people, because you are going to make the bright future of India, doctors next to God. Bye. Bye to all of you. Bye kids. Bye. 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 Bye kids. Bye. Bye. Bye to all of you.